Tradoon. this usually take?
Shivering and immediate return. Shoot the radar into the ground and the bone bounces the image back. Bounces it back. This new program's incredible. A few more years development and we won't even have to dig anymore.
Where's the fun in that?
It's a little distorted, but I don't think it's a computer.
Oh. Post-mortem contraction of the posterior neck ligaments. Velociraptor?
Yeah, it's good shape, too. It's 5, 6 feet high, I'm guessing 9 feet long. Look at the extraordinary...
What'd you do?
He touched it. Dr. Grant's not mission compatible.
They got it in for me. And look at the half-moon-shaped bones on the wrist. It's no wonder these guys learn how to fly.
That doesn't look very scary. More like a 6-foot turkey.
Turkey,
Turkey.
Well, maybe dinosaurs have more in common with present-day birds than they do with reptiles.
Look at the pubic bone, turned backward, just like a bird. Look at the vertebrae, full of air sacs and hollows,
More
just
like
like a
a
bird.
6-foot turkey. Turkey.
Six-foot turkey. Turkey, huh? 6-foot turkey. Okay. Try to imagine yourself in the Cretaceous period. Try to imagine yourself in the Cretaceous period. Imagine yourself in the Cretaceous period. You get your first look at this 6-foot turkey as you enter a clearing.
Well, hello everybody, and welcome back to Paleontologizing. So good to see all of you here today. Happy Wednesday, and we're getting a visit from the landlords right at the beginning of the stream, huh? Huh, sweetie pie? Yeah. Anyway, we're gonna have a fun stream today. We're gonna be talking about Triceratops quite a bit, I suspect. It's a brand new paper that just came out, I think today, on Triceratops' nasal anatomy. And what that might say about their metabolism and respiration and all of that. So, it's going to be cool to talk about. Haven't really even had a chance to read the paper yet, so we'll be doing that live. If anyone's here for the very first time, allow me to introduce myself real quick. Speak over Stephen Hawking here. My name is Danny Anduz. I'm a dinosaur paleontologist. So as a paleontologist, I work on fossils. As a dinosaur paleontologist, I mostly work on dinosaur fossils. Dinosaurs are what I study, what I publish on in the scientific literature, and what I talk about 4 days a week right here on Twitch, unless I'm in the field digging up dinosaurs, in which case I'm usually streaming 7 days a week from the field. We'll be doing that again from Wyoming and Utah, maybe even Montana this year. We'll have to see. But the whole point of these broadcasts is to try and bring fossil science to you at home, to give you an appreciation for why paleontology is important, how it's relevant to your everyday life, and to show you how it really works. Whether we're digging up fossils live in the field or going over new scientific papers or interviewing other paleontologists, the whole point is to give you an inside peek into how fossil science really works, what it's all about, and why you should care about it. Well, I think what Sweetie Pie here really cares about right now is getting paid. All right. Time to pay rent? Okay. Yeah. Here, let's go ahead and do that. Oh, Sweetie Pie. Is it rent payment time? Is that what time it is? Is that what time it is? Yeah. There we go. Ooh, look at those. Look at this. What do you think? You want to eat that? No? She goes, well, I mean, if it's right here, I suppose I might as well. It might otherwise go to waste, you know. And Saronglan, I'm glad you like her collar. Lordy got that for her. I suspect we're going to be seeing a lot of the cats on today's stream, given that I'm the only one home right now. So if they want attention, they have to come to me. Huh. Oh, look. There's another one. Different kind. It's one of the greenies. The dental treats. You can eat that? No, you're leaving the greenie? What? What? Oh, well. Welcome to Paleontologizing, everybody. It's good to have you here. If you've got any questions at all, not just about dinosaurs necessarily, but about other aspects of natural history, whether it's the fossil record, extinction, evolution, the origins of biodiversity, whatever you're curious about, even broadening it out to the philosophy of science in general, I'm here to answer those questions for you to the best of my ability, and, yeah. Don't be shy with those questions. It's kind of the bread and butter of our streams here. One of the primary components is talking to you in chat. Given this is a live medium, it's kind of the beauty of Twitch, you know, that interactivity. Too good for green. Lordy, how are you doing? Hello. Hope you're feeling a little bit better, Lordy. Can everybody send Lordy some get well soon wishes? She flew back to Ohio, where her parents live, to help with some medical stuff, and now she's feeling under the weather. Unrelated thing, but I'm sure she'd appreciate some well wishes. But yeah, and Thought Couture, we're gonna talk about that tomorrow, the Dinosaur Valley State Park in Texas. I need to gather some more information on that, but it is absolutely something we're going to be talking about. I'm going to find some petitions for us to sign and see if there's some other ways that people can actually, like, get involved to fight this thing. One of these AI data center scams. Yeah. Anyway. Yeah. But yeah, made a post to Blue Sky with a link. Thank you, Lenina. Okay. Yeah, let me check that out. There we go. There we go. Petition from the Sierra Club. Here, I'll give everybody a link to this right here if you want to take a look at it now. But I'm going to be gathering some resources so we can have a big talk about this tomorrow. Yeah. But this is directly relevant to us. One of the most beloved dinosaur footprint sites in the world is right there along the Paluxy River in Texas. Dinosaur Valley State Park. So yeah. Anyway, 2,600 acres. It's... We'll talk about this more tomorrow, but there are rumors floating around, unsubstantiated, but there are rumors that a lot of this, like, data center stuff is just land grabs in order to be able to build, like, detention centers, essentially like concentration camps on that land. Because, with a giant warehouse like that, when the AI bubble bursts, which it will do probably sooner rather than later, guess what they're going to be doing with those warehouses instead, Anywho, we'll talk about this more tomorrow. Yeah.
Let's protect our fossils, because
Edzors!
if they're removed,
Holy
America
cow.
loses them forever.
Thank you for the Prime sub there. I really appreciate that, Edzors. Thank you for helping support science outreach here on Twitch. Appreciate that very much. Anyway. And Chose Sportful says Conspiracy Land. I mean, that's the thing. I'm not saying that is what's going on, but those are rumors floating around, and again, this is why I'm not talking about this in depth today. I've got to get all my sources straight. I've got to be able to cite this information, all of that. So we'll be talking about this more in depth tomorrow. The whole point of these streams, like I said, is to do science outreach, to give people the best information that's available. Not just about natural history, but other stuff that touches on it, like this whole data center project thing that puts this fossil site at risk. That's directly relevant to fossil science. And again, we'll be talking about that tomorrow. So yeah. Andrew Memorex says, is the closest thing we have to a Triceratops today the rhinoceros? No, phylogenetically speaking, Andrew Memorex, the closest thing we have to a Triceratops is this animal. Or alternatively, this animal. Or alternatively, this animal. Birds are the closest living things to dinosaurs that we have today because they literally are dinosaurs. These are the only living dinosaurs on our planet. I say only, even though there are roughly 10,000 species of living bird. But yeah, birds are the closest living things to dinosaurs we have because they literally are dinosaurs. Does that make sense? Avian dinosaurs, exactly, Chose Sportful, yeah. 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 Andrew Memrick says, I mean, the way they were. No, the way they were and the way they are, yeah. I want to make that very clear. Birds literally are dinosaurs. So Triceratops is not particularly close to birds on the dinosaur family tree. These are just ornithischian dinosaurs. That's not really the consensus. Here we go. This is what we want. So Triceratops is a ceratopsid dinosaur. It's part of Marginocephalia. It's part of the ornithischian clade of dinosaurs, so it's on the opposite side of the family tree from birds. But it's still... birds are still much, 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 much closer to Triceratops than Triceratops is to, like, a mammal, such as a rhinoceros, you know? You're back so soon, sweetie pie? My goodness. There. Find... I don't know if they're gonna have rhinoceros on this cladogram, but they will have relatives like horses, probably. Right? Where's our perissodactyls? Do they not have perissodactyls in here? Dogs, cats, whales, pigs, mice. They have tree shrews, but they don't have any tapirs or horses or rhino. Oh, rhinos! There we go. It's right there. All right, so here's how closely related rhinos are to us. We are both placental mammals, rhinoceros and humans. We last shared a common ancestor about 95 million years ago. So human beings are way closer to rhinos than rhinos are to dinosaurs like Triceratops. So let me show you rhinos to Triceratops now. In order to get to their common ancestor, you've got to go way back to about 325 million years ago. This is where reptiles and mammals split. The sauropsids and the synapsids, respectively. Reptiles and mammals. It's the base of amniota, when living things, when vertebrates, I should say, came up onto land and then started laying hard-shelled eggs on land. When things kind of, to grossly oversimplify, when land vertebrates graduated from amphibians to critters that don't have to rely on water to lay their eggs and reproduce. Mammals and reptiles have been going in their separate directions ever since that initial point when critters started evolving land-based hard-shelled eggs that won't desiccate when they dry up. Does that make sense? So anyway, just making that point very emphatically. Triceratops and rhinoceros are not close relatives at all. And I don't really think that they're even that close in terms of, like, ecology. So, like, if we're thinking about big animals that walk around and do stuff, I don't think that the lifestyle of a Triceratops and that of a rhinoceros are really all that similar. We'll talk about that a bit more today. But rhinoceros they tend to be very solitary animals. They're not very social. Ceratopsids, like Triceratops, we've got lots of evidence that they were highly social animals. They lived in groups, hang out together. They had really showy display structures on their heads, like crests and, frills and horns and various episquamosals and epiparietals, lots of little accoutrements on those frills. Highly, highly social animals, we think, for the most part. Very different from rhinoceros. Triceratops also probably would have been a lot more, probably versatile in what they're eating. That big beak on the front, and then their dental battery, like this huge array of teeth that they have on the inside. They probably would have been able to tackle a much wider variety of plants than like a rhinoceros can. Rhinoceros today mostly eat grass, as I understand it. There were no grasses during the time of the dinosaurs. So Triceratops would have been eating lots of different kinds of plants instead. Yeah, the list goes on and on and on. Just because both of them have 4 legs and horns, those are superficial similarities that don't really mean much biologically, you know? When we're talking about these as living, breathing animals, that's surface level stuff, the horns and the 4 legs. So we'll get more into that today, as we talk about Triceratops paleobiology. Yeah. Anywho. Hello, sweetie pie. Look, you left some treats here. Look at that. No? She doesn't want it. See what I said where we're gonna have some cat company today? I'm the only game in town right now. If you want some attention, huh? Yeah. She's probably gonna be demanding that I end the stream early. We'll see, sweetie pie. We'll see. Yeah. Anywho, yeah. But yeah. And Science Streams. Oh, is it the single greatest science communicator? Professor Dan. You misspelled Balint Casso right there. Am I saying your last name correctly? If anybody's not yet following Balint of Science Streams, missing out. I'm really glad we got to raid into science last night. Lita was streaming, and that was super cool. Always cool to see Lita on screen. But Balint and Lita are a married couple of molecular and systems biologists. Well, actually, hang on. Yeah, Lita was saying that she would call herself a biochemist. She does a lot of biochemistry, at least. And she said Balint is not a biochemist. And the way that she said it almost sounded like a slight, even though I'm sure it wasn't intended that way, but it made me chuckle a little bit. Yeah. I think Balint might be... Are you more on the genetic side of things rather than the biochemistry side? I'm most certainly not, and it is a bit of a slight. Oh boy. I love your dynamic on stream, Balint and Lita. It's always a lot of fun. If you want to see that yourselves, you should go follow Science Streams, everybody. Excellent science outreach done by two, genuine research scientists. Two published researchers. Right here on Twitch. Go give them a follow. Yeah. Alright, let me scroll up, because I think there was another question about ceratopsids, maybe? Yeah. Let's see. Oh, Andrew Memerick says, I know that birds are living dinosaurs. I'm wondering if rhinos would be the closest thing we could look at that might give us an idea of what Triceratops were like and the way they used their horns. No, I think they would have been very different. That's an interesting thing about rhinoceros. All living species of rhinoceros. There's what, 5 or 6 living species, I think? White rhino, black rhino, Indian rhinoceros, Sumatran rhinoceros, Javan rhinoceros. And I think there's another one, it might be another subspecies from Africa. But I think there's about 5. We'll look them up on OneZoom, on our Tree of Life. But they all have very poor vision, as I understand it. They don't have good eyesight. They appreciate the world primarily through smell and hearing. And that would have been very different from dinosaurs, many of whom had excellent smell and hearing, but they were very visual animals for the most part. Unlike mammals. Mammals tend to be kind of olfactory first, nose first animals. Rhinoceros are kind of like that. They also have good hearing, terrible eyesight, as I understand it. And so the horns on a rhinoceros they're sometimes used for defense. Maybe they're used for showing off a little bit, but the horns and frill on Triceratops would have been primarily for display. Again, we'll talk more about that in a little bit. But, again, just because an animal has horns doesn't mean that it's like a similar kind of critter. It doesn't mean that it's a particularly good comparison in a, biological sense, I mean, think about the rhinoceros beetles that we have. These animals have a very different ecology to rhinoceros, but they get called rhinoceros beetles because they've got horns on them. They're part of their exoskeleton. It's got these big chitinous protrusions like that. It doesn't mean that they're actually similar to rhinoceros in any real sense. It's just it kind of reminded people of rhinos in the same way that Triceratops reminds people of a rhinoceros today. I can understand that impulse to try and make an analogy to kind of make things make better sense to you, but I don't know. I want to emphasize that these are very different animals, It actually reminds me of a thing when I was a kid. I must have been probably about 10 or 11 years old. And my mom was dating a guy at the time who had these elderly parents. And his mom, the like elderly mother, used to get on my case all the time about dinosaurs. She'd be like, "Are you sure that they're real? They look so ugly. I don't. Why are you interested? Why are you always reading books about them? Why don't you want to watch the TV?" And I remember at one point, I like, as a 10-year-old kid, or maybe freshly 11 years old, I like got sucked into an argument with her about whether or not rhinoceros were dinosaurs. Like, no, they're mammals. They're a very, very different kind of animal. She goes, "I don't know. I think they look very similar, and I think you're wrong about this." Like, great, thanks. Should I show you in the book? Should I show you the, what the scientific consensus is about this? She didn't want to hear about it. So anyway, this is a thing that kind of rankles me a little bit. You could call it a pet peeve almost. So yeah. Anywho. But yeah. Nothing ugly can be real. The TV says so, says Casey Snowart. I mean, yeah. I don't know. Oscar, thank you. Shark Geek, how are you doing? Can we get a shout out for Shark Geek too? And for Casey Snowart? And for Petrodactylus. Let's do a threefer right there.
Oh, baby, a triple! Oh, yeah!
We have so many cool streamers here in the chat right now. And you should really give all three of them a follow if you're not yet doing so. Shark Geek, as his name implies, works on sharks. Outreach and education about these incredible animals geared toward conservation. Shark Geek's a really cool guy. He knows a lot about sharks, and he wants you to know a lot about sharks and to appreciate these animals and protect them, because holy cow, are sharks in trouble nowadays, and they get a bad rap, Sometimes I wish that, like, those antiquated words for sharks would come back. Back in the old days, in like the 1800s, 1700s, sailors would refer to sharks as sea dogs. And, it kind of reminds me of the nickname swamp puppy for alligators. It gives them a more kind of endearing sort of feel, We should have that kind of attitude towards sharks. They're incredibly important animals, and they are so maligned. If you want to learn more about them, you should go follow Shark Geek right now. Casey Snowart, whom we raided into on Monday, right? Casey does art here on Twitch, often geared toward conservation as well, especially for critters like the vaquita porpoise. But Casey does really, really cool stuff on here. Accomplished artist, she wants to teach you how to draw. And she's good at it, Her philosophy is, not to put words in your mouth, Casey, but anybody can be good at drawing. You just have to put in a little bit of work. Stick with it a little bit, but you can find so much joy and fulfillment in doing that. And with her interactive streams, the art gyms and stuff like that. Gym like exercise, like gymnasium. Go exercise in the art gym. Improve your artistic skills in a really laid-back, chill, non-judgmental environment. It's a cool place to be, so go follow Casey Snowart. And likewise, Petrodactylus, who does a lot of gaming, but I've met Petrodactylus in person as well, alongside Casey and Shark Geek. And Petrodactylus is really cool. Her streams are also very chill and just fun. Hang on, I'm hearing weird noises coming from the 3D printer. Let me check on this real quick. But yeah, go follow Shark Geek, Casey Snowart, and Petrodactylus if you're not yet doing so. I will be right back. I gotta check on this. There we go. Sorry about that. I had to change out the filament there. We started to run out. But I am currently 3D printing another leatherback turtle bobblehead. And looking forward to giving these as gifts and peace offerings. Peace offerings, like there's any hostility there. As gifts and thank yous to some of the leatherback turtle researchers and conservationists that I'm hoping to work with soon. And also to some of the people that we've interviewed already, like Scott Benson and Jeanette Weineken. I'll be sending some of these to them. This is something that I'm pretty proud of, actually. It's been a really fun project putting this together. Let me find it for you. Scrolling down a little bit. Let's find that. Leatherback turtle bobblehead. There we go. Haha. Not painted yet. I still got to figure out how to paint these in an efficient way, but it's going to be a lot of fun. This is an animal that I'm super excited about, and we're going to be getting more and more involved with as the year continues. I've got a trip that's starting to come together for...
One of these archaeologist fellas.
Well,
Hang on.
it's pretty near the mark. Actually, I'm a...
Dafshu and their 13 raiders would also like
we
to dig deeper.
Thank you, Daft Shoe, for the raid. Welcome to Paleontologizing.
For still more protection,
Holy cow.
he simply grew spears which projected from his body armor.
Thank you. How was your stream, Daft Shoe? Live 2D rigger and variety streamer. Very cool. Welcome to Paleontologizing. It's good to have you here. And hello to you, Crystal Hero MB. What's shaking? That was such a cute little one. Oh, thank you. Yeah, this is here. I can show this to you right over here. Have I got it? Shoot. There we go. Yeah, here we are. Yeah, this is a 3D printed leatherback turtle bobblehead. I can't claim complete credit for this because I modified a previously existing file. I am big into the head and I made a lot of modifications to make it work as a bobblehead. But I'm excited about this. I'm getting involved with these animals and leatherback turtle research and conservation this year. So, yeah, I've been 3D printing a bunch of these to be able to give as thank you gifts to a bunch of leatherback turtle researchers and conservationists who we're going to be working with this year. So yeah, good stuff. The stream went well. Oh, excellent, Dafshu. Excellent. Demetrio Zanetti, how are you doing? Hello. Welcome. Now you can ethically boop a leatherback, kinda. Exactly, Sharky. Yeah. It's gonna be good. For anybody who is new here, who just came in with Dafshu, let me play a quick little channel trailer to introduce you to the stream and kind of demonstrate what we're all about here.
My name is Danny Anduz. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs. A limb bone from a new duck-billed dinosaur. I invite you to tune in and experience the adventure of fossil science. And now you're here. Welcome. Yeah. Good stuff. Anyway, I really appreciate your raid, Dafshu. And hello to everybody who's come along with you. Let me know if you happen to have any questions about natural history, about the fossil record, about extinction, evolution, the origins of biodiversity, or maybe most especially dinosaurs, which are what I happen to study, what I publish on in the scientific literature, what I dig up in the field, all that good stuff. We spent 11 weeks in the field last year. 11 weeks. And streamed nearly every day from out in the Badlands of Utah and Wyoming. We're going to be doing more of that this year. Maybe not more than 11 weeks, but we'll see. I'm also hoping in May to be able to go out to Florida in order to show you this incredible animal. Dermichelys coriacea, the leatherback turtle. This is a real video, by the way. One of the world's largest living reptiles. A completely superlative creature in so many different ways. They are astonishing animals. And they're in desperate need of our help. Even though they are survivors from the age of dinosaurs, their fossil record goes back at least about 80 million years. Today they are in serious trouble. Their population numbers around the globe have declined by like 95% or more. And they could go extinct within the next couple decades if we don't do something now to help them. So I'm trying to get the word out about these creatures and get people to care about them, you know? Because they are astonishing animals. So we're going to be talking a lot about leatherback turtles. And again, I'm hoping, fingers crossed, we can take this channel out to Florida in May and maybe see some leatherbacks live and in person. Incredible animals, and I can't wait to show them to you in person, you know? So yeah. Anywho. Before I forget, let me do a Blue Sky post real quick. And then we'll do some Metazoa to start off the stream. There we go. Take a screenshot there. See if this is usable. Yeah, that'll work. You know what? It's kind of a goofy expression. We could do better than that. You know what? Actually, that light might even be too bright, given that I've got a light-colored shirt on today. I'm trying to think like an artist here. There we go. That's a little better. Alright, let's see if that's an improvement. It is. We'll use that. Excellent. Get that posted here to Blue Sky. There we go. I've got a feeling it's gonna be a Triceratops heavy stream today, as my backdrop might indicate, since we'll be discussing the new... Who are the authors on this new paper? Here. Is it Tada et al? Seshiro Tada? Yeah. The soundboard is gonna go berserk for a second because I'm gonna type an M dash out.
What? That belongs in a museum.
Apologies, it happens when I have to use the notepad. But we'll chat about. Well, we'll talk about whatever chat is curious about too. Join us and hang out at twitch.tv/Paleontologizing. Nice. All right. All kinds of Triceratops on the wall behind me, including a 3D printed scan of Triceratops brow horn. There we go. And paleontologizing, no typos detected. Let's post it.
Hold on to your butts.
There we go. I appreciate your patience while I work on these things, chat, while we post a going live message like that. There we go. Excellent. There's a link in the chat if you'd like to interact with that post in whatever way. But Blue Sky pretty much is my primary social media nowadays, aside from Twitch, obviously. So, and I really should post on there more often. By way of contrast, I don't think I've posted to Instagram in like 2 years now. It's just no fun. Blue Sky, I like a whole lot more. So yeah, if you ever need to get hold of me, that might be a good way to do it too, aside from my email. But yeah. And Murph says, do all ceratopsians have all the horns? Good question. The answer is no. I can prove it to you. Try not to wreck everything. There we go. Protoceratops. I don't know if you could really call this a horn on the nose. I probably wouldn't. And no brow horns either. Protoceratops is a ceratopsian, but it is not a ceratopsid. And not even all ceratopsids have horns either. I'll show you. Okay. Here we are. This'll work. Excellent. So, this is an evolutionary family tree. This will be relevant in a couple minutes when we do Metazoa. Triceratops is the most famous of these ceratopsids. And this should really say Ceratopsidae up here. But the ceratopsids are the big, mostly horned ceratopsians. So Triceratops, Pentaceratops, Aeneosaurus, Styracosaurus, Chasmosaurus, Pachyrhinosaurus. These are all ceratopsids. So these are the big guys. So Ceratopsidae is a smaller group within Ceratopsia. So Ceratopsia includes critters going as far back as Psittacosaurus here, who doesn't really have horns unless you count the cheek spikes, the jugal horns. But which maybe you could call them horns if you want to. But yeah, it doesn't have a frill either. It does have a little shelf on the back of the skull. But, oh yeah, this is from Gaston Design. Excellent. Rob Gaston made these. So you can purchase this ethically from Rob Gaston, whose workshop we got to do a live streamed tour of in 2024. Anyway, so this is also a ceratopsian, but not a ceratopsid. So to answer your question, Murph, no, not all ceratopsians have horns at all, or even frills. But with the ceratopsids, they all have frills, and most of them have horns. An exception would be a critter like Pachyrhinosaurus, which I guess it kind of, you could maybe say that it does have horns if you're talking about those spikes coming off of the center line of the frill, kind of behind the eyes. But it's debatable, you know? But they famously just have this big, rough nasal boss on their nose. So no brow horns and no nasal horns on these guys. Probably. There's always a chance that maybe they had a big keratin nasal horn there. And that's actually a project I'd really like to see pursued. Yeah. No jugal horns, says Murph. They do have jugal... It depends whether or not you want to call them horns. But they definitely do have the big jugal spikes, yeah. Yeah, they're not necessarily as pronounced as they are in other dinosaurs like Pentaceratops. The name Pentaceratops means five-horned face. But they might have more horns, and they might have fewer, depending on how you count them. They've got three, like Triceratops. And then they've got these big jugal protuberances here. Whether or not you call that a horn is kind of up to you. Whether or not you call these horns is kind of up to you, too. We call these epis. Actually, we call this one an epi, too. You've got the episquamosals, which are attached to the squamosal bone. The epiparietals, which are attached to the parietal bones. And then the epijugal, which attaches to the jugal bone here, cheekbone. I probably wouldn't call those horns. Like, it would feel weird for me to call them horns. If I'm digging up this animal in the field, I'm not going to say, oh, we have a horn over here. If I find one of the epis, I'd say we have an epi over here. Episquamosal, epiparietal, or epijugal. But these are the little triangular hornlet type things. But I wouldn't call them horns. If I'm talking about these animals with colleagues, I would refer to these three as horns and the rest as epis, if that makes sense. Epiparietals and episquamosals. There we go. So here they are on... These are episquamosals on various ceratopsids. So these are from, like, the like, lower corners of the frill, so to speak. So, yeah. What's interesting is that in a lot of these guys, those epis, they start off as separate bones when the animal is young. So they're not attached. And then as the animal grows and matures, they kind of widen out and they fuse on to the margin of the frill. So what used to be a separate bone fuses up with the rest of the skull. It's really cool how that works. Like Triceratops does this. Here we go. Beautiful. So this is a scan of the Juvitrike 3 Triceratops skull. That's the name of this site is Juvitrike 3. Denver Fowler's dad actually discovered this. Or no, maybe Denver discovered it and his dad helped excavate it. I forget. But anyway, you'll notice over here the epis, the episquamosals, and the parietals up here. These are not fused on yet. As the animal grows and matures, those flatten out, they become wider and wider, and that juncture between them kind of disappears. They fuse on to the skull bones. Super cool. So Game Over says, based on that, what defines a horn? I guess... You know, I don't know if we have a really good hard and fast definition of what a horn is. There are different kinds of animals that have things that we would call horns. And they're made of very different stuff. So like we were talking about rhinoceros earlier, they are completely different. So you look at an animal like a rhino. This is a black rhino right here. You can tell because the mouth comes to a sharper point than a white rhino. Here's a white rhino, where the mouth is more straight across. It's more wide. That's actually where the name white rhino comes from. It's a mistranslation of wide. Anyway, their horns are not made of bone. So you look at a rhinoceros skull, there's just a big lump on the nose there. In life, it's covered by a layer of keratin that forms the actual horn itself. It's the same kind of material as, there's a woolly rhinoceros skull right there. Same kind of material as our fingernails. It's made of keratin, but it's not actually like bone. It's not part of the skull. So we call that a horn. And yet, with other creatures that have got a similar thing, we might call it an antler or something like that. Like, it's very different from, say, Triceratops, where the horns have a bony core on the inside. So what you're looking at here is just the bone. There would have been a sheath of keratin over the top of this. And the same way that, like, your dog or cat, they have a keratin sheath over their claws. So, like, when you're trimming the claws of a dog or cat, you have to be really careful not to go too deep with it. Yeah, here we go. So there's the bony core underneath, and then there's a keratin sheath over the top. The keratin sheath, again, made of the same material as our fingernails. It's the same way with the Triceratops horn. This is the underlying bone that's been fossilized, but in life there would have been a soft tissue keratin covering over the top that would have made the horn even longer and sharper, to the point where, with some of these guys, the horns were crazy long. So like with the Yoshi's trike specimen that I helped excavate back in 2011, this animal had stupendously long horns because, again, here you're only looking at the bony core there. The horns would have been even longer when the animal was alive. Super cool to think about. Yeah, here's a PaleoStream reconstruction of Yoshi's trike there. Super long. But yeah, pretty neat, right? And there's some debate as to how long that keratin sheath would be, because to my knowledge, we've never really found that on a Triceratops horn. We've never actually found the keratinous sheath to tell exactly how long the horn in life would be. We have to kind of guess just based on how long the bony core is. Does that make sense? We heard from Paul Serino that they have a mummified Triceratops, one with, like, preserved skin, indication of what the exterior looked like. I'm so curious about that because I would love to hear that they have keratinous sheaths for the horns. So we might finally have hard evidence for how long the horns would be in life. How much longer do they extend past the bony core? But yeah. And Petrodactylus says the claws thing, it's the same with lizards. My bearded dragons need nail trims from time to time. She also has a quick I need to be careful button. Exactly. Yeah. Yeah. And Lord Prettybeard says you could also look at pronghorns as an example. They split the difference between horns and antlers. Kind of, yeah. Like, pronghorns are really cool animals. And it's always a joy to see them in the field. I see a lot of them during the summer when I'm out there in Wyoming and Utah. but they're mammals, and so they're not always the best kind of analogy for dinosaurs. You know, when we're talking about dinosaurs, we usually try and look at their closest living relatives, who were crocs, who were kind of cousins to the dinosaurs, and then birds, who were living dinosaurs. If we have to dip into mammals to draw analogies, then we're kind of in the realm of more speculativeness, if that makes sense. But yeah. Anywho. And Murph says, I heard at a museum that some keratin found was 1.5 times the diameters of the bone. Yeah, that sounds about right, yeah. We have a general idea about this for claws, like, here, when I was visiting the museum in Blanding, there we go. There's a really cool display that showed the claw on Suchomimus. Here we go. The one. Yeah, really neat. And check this out. This is a baryonyx claw right here. I have the same one here, or rather a 3D print at home. I'm very familiar with this specimen. This is the one at the British Museum. So that's the bony core right there. And if you go around the side, there it is reconstructed with the keratin on the top. Yep. So birds are kind of the same way, where they've got a bony core to their claws, but that doesn't show you how big the actual claw would be in life. That's really neat. I love that. So this is speculative. We don't know that the claw was necessarily this long, but if we look at modern animals with bony cores to their claws, like, say, birds, and we look at the ratio between the length of the total complete claw and the length of the bony core, what we call the bony ungule, then we can have a rough approximation for, like, that ratio, how long we should make the claw sheaths on dinosaurs, and it's about like this. I think this maps out to, like, how big the claw should be with the keratin sheath over the top. Yeah, really neat. Cool stuff. Here's a link to this VOD if you'd like to watch that. There we go. So yeah. And Crimson says, besides feathers, do we have any signs of keratin on dinosaurs? We do. There are some dinosaur fossils that do actually have keratinous sheaths. I should have said that earlier. So a few of them from Liaoning show that, as well as... There we go. This just came out, last year? Back in March. Duonicus, this big two-fingered therizinosaur. There is preserved keratin over the claw that gives us an idea of how long it would be, I think. Yeah, the claws are approximately 30 centimeters long and show evidence of a keratin sheath. Because keratin decays quickly, it is not usually fossilized. The paleontologists say it was a stroke of good luck that the fossil was preserved in 3D, noting that they give a much clearer picture of what the dinosaur would have looked like when alive. Pretty awesome. I remember seeing a poster about this at SVP in 2024, and I couldn't wait until it was published and I could talk about it on stream. But yeah, you have part of the keratin sheath there. It's a little degraded, but it shows you roughly how long the claw would be. Pretty neat depiction there. And what a cool animal. Duonicus. This big plant-eating theropod dinosaur. Awesome. Yeah. But yeah. Yeah, what a neat animal. And the Lost Aussie says, very quick sidestep momentarily, you should look up Bastiodon. It almost sounds like a fossil mammal genus. It's a Pokemon. modeled after ceratopsians. Really? Let's take a look. Oh, interesting. Okay. It's got like Nasutoceratops type horns coming off the head there. No nasal horn, but interesting. Huh. Yeah, okay. But that reminds me of this guy. Nasutoceratops. He's got almost like bison style or you know, bull style horns. I wonder if this was inspiration. I wonder when that Pokemon came out. It's funny, there's like hundreds of them now that I don't know. I was briefly interested in Pokemon for like a year when I was in like 2nd grade. And I think there was maybe like 100 of them back then. And so I know nothing about any of the ones since then. But there's over 1,000 Pokemon now? What? Holy cow, Petrodactylus. How does anybody keep track? You know? None of them have been synonymized? They're all... How does that work? Are they being discovered all the time? Are they being split due to, like, DNA evidence? Like, these are populations that it turns out don't actually share genes, and so they... How does one make that determination that there's that many now, you know? I don't even get that. Anyhow. Nasutoceratops, cool critter. Due to monetary drift, there you go, Murph. Yeah, gotta be making that Skrilla, you know. Do they ever just put a new hat on any of the old ones and say it's a new Pokemon?
Tradoon.
So people have to buy that one now? Because it has a new hat, you know? Like Malibu Stacy. Stipe 1, thank you for the follow. Welcome to Paleontologizing. It's good to have you. There's a fossil researcher in the games named Kara Liss, and the fossil Pokemon she gives you are references to the mix-ups in the Bone Wars. Is that true, Petrodactylus? Interesting. Yeah. Anyway, before I forget, let's get into Metazoa here, and yeah, here we go. Here is our daily animal guessing challenge. We're going to try and figure out what our mystery animal of the day is by using an evolutionary family tree to kind of narrow it down. This is something I like to do pretty much every day on stream whenever I remember, because it's an excellent opportunity to talk about phylogeny. Every living thing on our planet can be classified on a grand tree of life like this, including ourselves, good old Homo sapiens. Not old, we're actually very new on this planet. We'll go back about 200,000 years for our anatomically modern humans. There's us, not really in our native habitat, but that's okay. Next to the bonobos and the chimps and the gorillas and the orangutans. All life on our planet, as far as we know, is descended from a single common ancestor about 3.5 billion years ago. Maybe more, maybe a little less. What's a few 100 million years between friends? So all living things are related. They all share DNA. So we can actually, like, test that. We can quantify how closely related different living things are. Not just using genetic information, but using the fossil record and morphology and other lines of evidence like that. That's what allows us to do this game and try and figure out the mystery animal in 20 guesses or fewer. Let's dive in and try and figure out our mystery animal for today.
Hold on to your butts.
Here we go. This game is kind of heavily tilted toward mammals to a certain extent. Mammals are overrepresented in Metazoa, which makes sense. This game was programmed by mammals, so fair enough. Give me the name of a mammal, a placental mammal. So no marsupials, no monotremes. Give me the name of a placental mammal, chat. And we'll start there. And hopefully that'll knock out a few guesses. Alexander Morrison says, pig. Okay, let's do pig. El cochino. The pig. Okay. Oh, ho, ho. Oh, see, this is why we start with a mammal most of the time. Because it usually saves us a few guesses, at least. Our critter is not a pig, but it is a Laurasiathere, which is a specific group of mammals that includes pigs and our mystery animal of the day. So this is how Metazoa works. We guessed pig. Metazoa says, nope, not a pig. Best I can do for you today is Laurasiatheria. So, let's jump to pig first on our tree of life. Piggos are over here. There we go. Pigs. There are 9 species within genus Sus today. But our critter is not a pig. Metazoa said Laurasiatheria. So that's going to take us to here. Carnivorans, bats, hedgehogs, and more. And pigs. Being kind of artiodactyl. So our critter is a Laurasiathere. So with one guess, we've been able to narrow it down from over 1 million species of animals down to about 2,000. Pretty good with one guess, right? But we can get even more specific than that because we guessed pig, which is a kind of artiodactyl, an even-toed or cloven-hoofed ungulate. So we know it can't be one of these, or else it would have said artiodactyla, and it didn't. So our critter could be a... Are these scrotiferans? I always ask myself this. Let's look it up. Yeah, here we go. Carnivorans. Oh, it includes artiodactyls. Never mind. Okay. So I guess this is Scrotifera here. This is a different clade. What do we call this one? Perissodactylomorpha. Ungulata. Well, that's the... I guess the trees on the phylogenies in Wikipedia are not really matching what's here on OneZoom, but that's okay. Anyway, so our critter could still be a bat. Or it could be... Well, here, I want to knock out Eulipotyphla real quick. The insectivores. I doubt it's going to be one of these guys. They're not very speciose in the grand scheme of things. And I don't think there's many of them in Metazoa, but we're going to do it anyway. Let's try and knock out Eulipotyphla. Let's guess a... Are hedgehogs part of this clade? They should be, right? They're not anymore, I forget. No, they are. There's hedgehogs. Let's knock out the hedgehogs. Let's knock out Eulipotyphlans. Just in case, you know? We might be throwing away a guess here, but I want to be sure that our critter is not a Eulipotyphlan, because that's the earliest branching clade within this larger clade. So let's try that. And... yeah, okay. It's not a Eulipotyphlan. Probably didn't need to do that, but it's nice for peace of mind, just so we know we're not missing that. Okay, our critter... We know it's not an artiodactyl, so we've knocked out this branch and this branch here. It could still be a perissodactyl. These are the horses and rhinos and tapirs. Or it could be a bat. Oh, or it could be a carnivoran, right? Yeah, don't let me forget the carnivorans, who are very speciose. Let's try a carnivoran real quick. A lion or tiger or bear, or a weasel or a hyena, or a walrus or a whatever. Badger, says Cacklinsurf. That's a good one. That's a kind of, a badger is a member of Mustelidae, the weasel family. Let's try badger. And let's see if we can knock out the carnivoran clade, or maybe it will be a carnivoran. Let's see.
Hold on to your butts.
Okay. Okay, that was an excellent guess, because while it's not a badger, it is a member of the weasel family. Mustelidae. We're getting closer. This is good. This is good. There we go. The weasels. Mustela or Mustelidae? Where's Mustelidae? I wish these would give the clade names, but they don't. That's kind of an oversight. Mustelidae, the weasel family. So this includes weasels, badgers, minks, stoats, marmots. No, marmots are rodents. What am I talking about? I'm thinking about that Simpsons clip.
Here you go, boy. Suit's on. Huh? Hmm? Hmm? Hey, if you're out here, then who's in there? Whoa, a badger! Sorry, man, you can't crash here. Come on, let's go. Well, boy, looks like you got yourself a roommate. Come on, Lise, there's gotta be a way to lure that badger out.
Well, according to whatbadgerseat.com, badgers subsist primarily on a diet of stoats, voles, and marmots.
Stoats.
Stoats are weasels, Bart. They don't come in cans.
Then what's this?
That says corn, Bart.
Must you...
Anyway. Stoats are a kind of weasel. They are part of Mustelidae. This clade right here. Yeah. And Rushwing says there are American badgers? I only know about the European ones? Holy cow, Rushwing. Yes, absolutely. They are not like your, your friendly, well-mannered European badgers. American badgers are... I've heard them described as rabid, murderous, bloodthirsty. They're a bit more formidable than your European badgers, for sure. Tough customers, says Murph. Yeah. Oh, yeah. Yeah. American badgers are... Oh, boy. Yeah. Here's one chasing away a puma, a mountain lion, a cougar, whatever you want to call it. There's an American badger there. What happened to the sound? This is all dubbed in anyway. that wasn't as dramatic as I was hoping, but here's an American badger versus some coyotes. Digging around in the snow. Some coyotes show up. And that badger's like, get out of here! I will end you. I'll eat you and your babies, says the badger. I'll eat your whole family. Yeah, they're formidable animals. They really are. Toilet Gator says, yeah, unlike European badgers, instead of tea and crumpets, the American badgers have 4 locos and anger. Oh, yeah. Yeah. They are so flat, must be where they store all the anger. I saw a couple of badgers last summer in person, which was really cool, out in the wild in Wyoming. And that was a real treat. Fisher and I just saw this weird, big flat thing galumphing across the road as we were driving out to the Turtle Hill site. And we're like, what is that? And I stopped the car, and it's a badger. And then after it crossed the road, it got up from the ditch and just kind of glowered at us. I'm looking for the photo right now, because it's a pretty decent photo, actually. I posted it to iNaturalist. Shoot, where did that go? It was pretty neat being able to see that critter. But I've seen a number of badgers in the field. And again, it always feels special when you get to see one. They're shy animals. Like they don't want attention, but they will absolutely try and tear the face off of anybody who threatens them. There we go. There's that badger there. Just sticking his head up out of the ditch on the side of the road, and he's like, you drive that car over here, and I will run you off the road and eat your eyeballs. You don't want to mess with these animals. You leave them alone, and they'll leave you alone, but oh boy. Yeah. And wolverines are the bigger polar version of badgers. They are related, yeah. Yeah. They're pretty cool animals. They really are. Oh man, American badgers. It's interesting, like the difference in temperament between American and European badgers. It does make me wonder how long ago they diverged from one another. We should look at that real quick. Genus Meles, badgers. So, American badger. It's an entirely different genus from the European badger. Taxidea taxus for the American badger, and the European badger, or rather Eurasian badger, is Meles meles. And so these critters diverged from one another over 20 million years ago. So they've been very different for a long time. I guess that makes sense. A while back, says Golganek. Yes. Yeah. And let's see where wolverines are here, because they are related, but I don't know how closely related. Yeah, gulo. So wolverines are over here. They are related to martens, who are, oh shoot, there's the yellow-throated marten. I did a video about these guys long before I started on Twitch. They are also formidable animals. Let's find that real quick. There we go.
Using range data, we can come up with our most likely candidates, and then parse it down from there. The dentary seems to be the wrong shape for the Indian gray mongoose, and the limbs appear to be too long for the small Asian mongoose. The apparent lack of a sagittal crest seems to be another giveaway. I could be wrong, but I don't think this thing is a mongoose. So then, by process of elimination, that leaves us with this little guy. Yellow-throated marten. Scientific binomial, Martes flavigula.
These guys are a force to be
Russian
reckoned with.
speakers as the kharza. It's a common animal in that part of the world, and relatively well studied. As a member of the weasel family, the yellow-throated marten is closely related to the pine marten of Europe and the American marten of the western US and Canada.
And then wolverines
although
too,
it's
outside
slightly
of that.
larger and more primitive. Multi-gene phylogenetic analysis seems to indicate that it diverged from its relatives in the early Pliocene, and then hung around doing its thing in Asia until the current day. While it might look cute with its handsome, brightly colored coat, the yellow-throated marten also has some serious moxie.
Oh yeah.
And it isn't afraid to attack and eat animals much larger than itself, apparently including small deer.
Yeah, holy
for
cow.
being
They are formidable animals. Holy moly. If they were just a little bit bigger, they would probably, like, we would probably be on the menu, you know? It reminds me that other mustelids, like, shoot, who's the giant African, possibly terrestrial otter from the Pleistocene? Yeah. And Hydriodon? So this is from Prehistoric Planet. I just saw this a little while ago. There you go, Golganek. Yeah, yeah. So these are, what, Homotherium, I think? Scimitar-toothed cats? Bingo. So again, all these guys went extinct at the end of the last ice age. Uh-oh. Here they gotta watch out for weasels. Woozles, even. What is that? If a weasel steals that zebra, says Ice Allen, just you wait. Just you wait. Look at these guys. Oh, man. This is a pretty recent discovery, too, as I understand it. Yep. 10 feet long. So these guys, they probably ate some of our ancestors back in the day, you know? Yeah. Shoot. How cool is that, you know? Otter von Beitmark. There you go. Hit it, yeah. They're little babies. Probably more than 500 pounds there, Hogan, yeah. Yeah. The mustelids, man, they can be formidable creatures. Absolutely. This is one of the things I love about Prehistoric Planet is trying to show people these different critters that they wouldn't otherwise be aware of, you know? Pretty neat. RJN, thank you for the follow. Welcome to Paleontologizing. Good to have you here. Here, let's get some more information on this critter. And Hydriodon, here we go. Extinct genus of otters from Africa and South Asia, really. Late Miocene to the early Pleistocene. The exact sizes and lengths of Enhydriodon are unknown, given the lack of complete fossils. African species are estimated to be heavier than the extant lutrines. That would make sense. They'd be heavier than living otters. 3 species were estimated to weigh over 100 kilos, over 220 pounds. Given these weight estimates, the 3 species likely reached sizes comparable to extant bears or lions, making them the largest known mustelids to exist, the largest members of the weasel family. Although a lack of complete specimens makes precise estimates impossible. So we still need complete skeletons of these animals. And they're out there. Somebody's gonna find these someday. But right now it's still mystery. It's still a blank spot on the map. But somebody will find them someday. And maybe it'll be somebody watching this broadcast right now. You know? There's so many cool discoveries yet to be made in fossil science, and this is one of them, you know? It's a reminder that we should, if we can, always go out there and do more field work. Look for more fossils, collect more data. You know, the truth is out there. Just gotta go out and find it, you know? Say what? The 10-foot prehistoric otters are heavier than modern-day otters? Yeah, it's Wikipedia being careful, you know? Whoever was writing and editing that, you know, they're doing things the right way. Yeah. And is the type of geology they were found in known to be good for providing well-preserved fossils of other critters? I think so, Crimson, yeah. Yeah. I think it's just one of those things where, like, we just need more field crews out there. Someday we'll find a complete skeleton, and it'll amaze the world, but it hasn't happened yet. Yeah. Same issue with Sebecid size estimates? Exactly, Alexander, yeah. Yeah. If you thought the giant otters from the Amazon are bad now, imagine angering these critters. Oh, yeah. They probably were eating our ancestors in the early Pleistocene. So, at least on occasion. So our ancestors from the early Pleistocene. I'm not a paleoanthropologist. I don't know this off the top of my head, but I think Lucy is what, Pliocene? Australopithecus afarensis is what age? Yeah, Pliocene of East Africa. So this might be like Homo heidelbergensis? Archaic human. Middle Pleistocene of Europe and Africa. So whoever predates heidelbergensis is, that was probably on the menu for, on the menu for these giant terrestrial otters? I guess Homo erectus. Okay. Pleistocene spanning nearly 2 million years. Yeah, yeah. So good old H. erectus was probably on the menu for these giant otters, at least on occasion. Interesting that our forebears were probably eaten by giant land-dwelling otters. That's both terrifying and also really cool to think about, you know? I think in hindsight it's really cool. I mean, given that we're here today, you know, our ancestors made it through. I hope it doesn't sound morbid to say that, like, I think it's kind of neat that there were giant otters who were probably eating our ancestors, at least every once in a while, you know? Yeah. Mustela, there you go, Dismountus, yeah. Anywho, I'm getting super distracted. We're doing Metazoo. That's how we got onto this tangent in the first place. Our critter is a mustelid, but it's not a badger. So here, again, badgers were over here. So it's probably something more basal. It could be... Yeah, our critter could be an otter or a skunk. Skunks are... I guess there's a bunch of different skunk genera. Okay. Mephitis is the one I was thinking of. So it could be a skunk or could be an otter. Let's try skunk and see if that gets us any closer. Again, because I'm thinking it's either going to be... Yeah, either an otter or a skunk. Yeah, let's try skunk.
Hold on to your butts.
Let's see here. And, okay. The skunk is earlier diverging than our critter. It's probably going to be an otter. We've got sea otter and river otter are our two choices. I'm going to leave this choice up to you, chat. We'll run a poll here. New poll. Sea otter or river otter. And start poll now. There we go. The choice is yours. Will we guess sea otter or river otter next? I'm guessing it's either one of the two. Like, it's probably going to be a coin toss. Like, pick which one you want. And abstain. Thank you, Golganek, for your honesty there. I appreciate it. Monster Thriller Brett Giant Otter Shark Geek. That would be cool. Alright, we're neck and neck. River Otter and Sea Otter evenly split. 8 votes to 8 votes. Somebody break this tie. Please. Oh, come on. There we go. Okay. River... No! We ended up with a 9-9. Why do you always do this, chat? Darn it. Great job, chat, says Murph. A tie. Again, why do I even run these polls, you know? Okay. I'm gonna guess sea otter because those are the otters that I've seen most recently in person. When I got to go down to Monterey with Lordy at the end of December, we saw a bunch of sea otters. I see sea otters by the seashore. Let's do sea otter.
Hold on to your butts.
Let's guess it. Yes! And Hydra lutris. This is such a cool animal. I love sea otters. They are really, really neat animals. Highly charismatic. And, oh boy. They're really cool. Let's watch a little video on sea otters. And I got that in 5 guesses. That's really good. Okay. Here, we'll post that to Blue Sky real quick. There we go. Excellent. And there you go, Petrodactylus, yeah. If you started off with a placental mammal every time, it would probably save you like 1 guess on average every time. But I understand the tradition if you want to start with king cobra every time, Petrodactylus. I know you're a herps person, right? Which herps is such a funny word. Like, reptiles are not closer to amphibians than they are to mammals. Reptiles are actually closer to mammals than reptiles or mammals are to amphibians, but we still say herps as a matter of convenience, I guess. But yeah. Anyway, the otters. Let's see if we've got like an animal fact files or animalogic video on them. Highly charismatic critter. Here we've got a video from Monterey Bay Aquarium. Well. Let's take a look at this.
100 years ago, sea otters were thought to be extinct along the California coastline. But thanks to people working together to protect our ocean, sea otters have been recovering over the last century.
Yep.
My name's Terry Nicholson. I'm a senior research biologist at the Monterey Bay Aquarium, and my team and I study sea otters off the coast of California.
A shout out for Monterey Bay Aquarium.
And we're here today to talk about the important role of sea otters in kelp forest ecosystems.
They are super important.
Kelp forests are healthier and more resilient to climate change when sea otters are living there.
One of the things that I find really interesting about sea otters is that they have been kind of doing their own sea otter thing for like, I think, tens of millions of years at this point. So sea otters are here. Marine Lontra felina. What? No. And Hydra lutris is the one we're looking at. Have sea otters evolved multiple times? Yeah, there we go. Sea otter and Hydra lutris. Weird. Okay, I guess they're more recent than I realized. They only diverged from the African clawless otter about 6 million years ago, give or take. That's surprising. Okay. I was going to say that even though they are marine, they live in the ocean, they're not that different from their land-living counterparts. From, you know, river otters and stuff. But if that time estimate is right, then they actually haven't been separate for that long. So that might explain why they look pretty morphologically similar. But, yeah.
Sea otters are keystone species, which just means it doesn't take that many sea otters to have a really large effect on the kelp forest ecosystem.
Yep. And Shark Geek says, some years ago I heard that the otters are being killed but not eaten by white sharks due to massive kelp forest loss. I want to say this was the result of warming oceans causing a spike in urchins. Do you know if the kelp forests are recovering? They are certainly recovering in certain areas, like around the Monterey Bay Aquarium, where they have this massive conservation effort that's ongoing. I think they'll talk about that here.
Sea otters are the smallest marine mammal and rely only on their fur to stay warm in their ocean habitat. So they need to...
And their fur is incredibly cool. I think it's got the highest density of follicles of any animal on our planet. Or any mammal, at least. Super, super dense fur. To the point where it's almost kind of legendary. And it made me feel really good at one point because back when I lived in Montana, I was flat broke at the time. Holy cow. So I used to go to the local cosmetology college to get my hair cut. Because you could get a haircut for $6 there. So I would do that. Sometimes you could pay $8 and have an advanced student cut your hair. It might take a couple hours, but like I had more time than I had money back then. And on multiple occasions, I got a compliment about my hair from a student where she'd be like, "Wow, your hair, it's so thick. It's like a sea otter's pelt." Like, thank you. It's the nicest thing anybody said about me in a long time.
to eat a lot. They have to actually eat a quarter of their body weight.
But I do not have 1 million hairs per square inch. My hair's not that thick. Yeah. And I do not eat half my body weight every day. Or at least I try not to.
To eat a lot. They have to actually eat a quarter of their body weight.
Sorry, a quarter of my
every
body
day
weight.
just to stay warm and survive
I don't eat 50 pounds every day. Definitely not.
in their cool ocean environment. Kelp forests are an ideal place for sea otters to find food because they provide homes and shelter and food for all the creatures that live
gotcha,
there.
Petra. Yeah.
Sea otters dive down from the surface of the ocean and they search along the bottom to find crabs, urchins, and abalone before bringing them back to the surface to eat.
That's one of the reasons why the at the Monterey Bay Aquarium they give the otters soft toys. Like they can't give them anything rigid or hard or resilient because they will just take any rocks or any hard objects that they can and they'll smash them against the glass of the enclosure. So everything that the otters handle has to be soft so they don't end up destroying their own enclosure. I always thought that was really funny.
Many animals eat kelp. And sea otters often eat these grazers.
Yep.
Without sea otters in kelp forest ecosystems, it can create incredible imbalances among the creatures.
Lordy says, I bet the otters yearn for something hard to smash. Yeah. I think so. Yeah. Imagine the catastrophe that could occur if, like, if like one of the keepers there, one of the marine biologists or otter handlers, if they like accidentally drop their car keys into the enclosure, they probably have special protocols around this where it's like, okay, nothing in your pockets, you know, no jewelry or anything, just on the off chance that the otters get hold of it, you know. Yeah.
That live there. And sometimes kelp forests can disappear entirely.
Yeah.
By eating a lot, sea otters are helping to control grazers and maintaining healthy kelp forests. Sea otters are thought to be extinct from overhunting during the maritime fur trade 100 years ago. But thanks to people working together to protect our ocean, sea otters have been growing in population numbers, and we've seen dramatic increases in kelp forests.
This is so cool. I mean, it goes back to this idea that I talk about a lot, that, you know, back in the day...
Sea otters are helping to control grazers and maintaining healthy kelp forests. Sea otters are thought to be extinct from overhunting during the maritime fur trade 100 years.
So, back in the day, like, it's wild to think about. Not too long ago, 100 years ago, a lot of people, maybe most people, hadn't really gotten the message about extinction. Again, this is wild to us to think about, and I think it's important to remember this. That up until very recently, people didn't think of animals and plants and other organisms as being like part of a larger ecosystem. They almost thought of them as just kind of like part of the background to our lives as human beings. It's like, oh yeah, you know, there's plants and animals and they kind of do their thing and, you know, they're just there. It's not like they can disappear or anything. People almost had like a supernatural view of other living things in the sense that like, oh yeah, you know, one deity or another just kind of placed these things here and we can take them for granted, you know. They'll always be here. They're just part of the background. Like, no, these are living things that are part of an ecosystem. They're part of this living community of different organisms, and if one of them disappears, that can have knock-on effects on other ones. You can completely lose them from a region. You can completely lose them globally. They can literally go extinct. And to this day, there are still a lot of people who kind of can't wrap their minds around this idea that living things are finite. You know, just like ourselves, plants and animals, they can die off. They can disappear. The people who were hunting these animals for their pelts, they either didn't know or didn't care enough to stop that overhunting. And we almost lost sea otters entirely as a result of that, you know? Yeah. Again, it's important to remember how recent, how new this idea, this concept of extinction is. Like, as human beings, we've had concepts and models of the atom for longer than we've had like a scientific concept of extinction, you know? The scientific idea of extinction is a more recent thing than like models of the atom. It's wild to think about, but it's true. People like Georges Cuvier back in the early 1800s. This guy helped introduce this idea of extinction. He's like, yeah, all these fossil organisms, mastodons and mammoths and critters like that we're finding under the streets of Paris, these animals are not around anymore. They are extinct. And a lot of people called him a heretic for this at the time. They're like, what are you talking about? God in his wisdom would never allow any of his special creatures to go extinct. That very idea is sacrilegious. You're a heretic. This is the early 1800s, you know, that people were having these arguments. It's not that long ago. Like, again, there are physics models of the atom that go back longer than that. Crazy, you know? Yeah. Anyway. And red cherry pie, we'll get into this in a minute. Like mass culture, pop culture, conservation, these things can go hand in hand. Well, I'm leading up to that here. But yeah.
Years ago.
Yeah.
But thanks to people working together to protect our ocean, sea otters have been growing in population numbers. And we've seen dramatic increases in kelp forests across Central California.
So this is the thing, is that like if we just leave these critters alone, give them a little bit of space, a little bit of breathing room, if we stop persecuting them, even just a little, they can start to bounce back. This is a recurring theme in conservation.
Sea otters play a very important role in balancing kelp forest ecosystems. The return of sea otters to their historical range throughout California could help kelp forests recover and restore their benefits to more places along the California coast. Thanks so much for watching. And if you want to learn anything more about sea otters and California coastal ecosystems, come visit us at MontereyBayAquarium.org.
There you go. Yeah. Cool stuff. Here's a link to this right here. But I'm really glad that you said that they're red cherry pie. Red Cherry Pie says, I think the biggest issue is people don't care. They'd rather know what the Kardashians are up to or whatever. It's such a shame how little the average person cares about animals aside from cats or dogs. I agree with you in part, but... Oh yeah, here. Take a look at this. Different celebrity
fans
here.
Of the iconic Taylor Swift to bring a classic 32-year-old Monterey Bay Aquarium t-shirt back to life. Liz McDonald, one of the masterminds behind honoring the Swifties' request, said this was an all-hands-on-deck effort.
We were in the archives digging through. We were contacting former aquarium staff members, all trying to find out. And then, of course, all the Swifties online were also doing their own sleuthing. And I think it was really a whole group effort to bring the aquarium and Liberty Graphics together so that we could make this happen.
This is the aquarium's way of saying thank you to Swift for the shout out and another.
So I guess Taylor Swift was wearing this t-shirt in some sort of media appearance, and then like Taylor Swift fans being one hesitates to use the word rabid, being highly enthusiastic. They really wanted this shirt too, and it ended up being a wonderful thing. I mean, holy cow, the Monterey Bay Aquarium, along with Liz McDonald, she was able to kind of spearhead this effort and produce a new run of these vintage shirts and use it as a fundraising event.
To her fans, who not only flooded the aquarium's comments, but supported the aquarium's mission the only way Swifties know how.
We also saw an uptick in $13 donations, which is wonderful. That's like a little thank you from the Swifties, so we really appreciate that.
The aquarium.
So I guess Taylor Swift fans are really into numerology, maybe? That's kind of the impression I get. I guess the number 13 has some sort of special cosmological significance to fans of Ms. Swift, but what a wonderful thing that resulted from this.
Aquarium added a special spin to claiming the tea. They're asking fans to donate $65.13 to match Swift, letting fans show their appreciation for the adorable sea otters and the aquarium's history of ocean conservation. Like always, Swift fans were ready for it.
I came out this morning, 9:40. I bought it 9:50, and I'm so excited for it to come.
After the fundraiser went live at 9:30 a.m. on Tuesday, $1 million out of the $1.3 million goal had been raised in just 5 hours.
Ever since I saw the movie.
In 5 hours! Holy cow. So, yeah. How cool is that? You know?
I've been like checking online, on Reddit, on social media, like, are they going to re-release a shirt?
Again, all the money raised will go back to the aquarium to help otters like Ivy, Ruby, and Opal, whose names happen to reference lyrics in the Stars songs.
And Opal, yeah, you know, her name was voted on by the fans, so we don't know. Was Taylor one of the ones who voted? I'm not sure. Who can say? But only she knows.
And Swift, leaving a permanent mark wherever she goes.
I love that there's a connection between Taylor Swift, who is an international pop star, and bringing in some local recognition to Monterey Bay Aquarium.
I feel like it's such a cool collab and just an amazing like show of the power of the Swifties.
In Monterey, I'm Jasmine DeJarnette, KSBW Action News 8.
Very cool. Here is a link to that video right here. And, I happen to be familiar with this shirt because Lordy actually bought me one for Christmas. Not because she is a Swiftie, but she just thought it was a cool shirt. I think she saw it on the news or something, and I think I have it right over here. Hang on. Hang on, let me find it. All back here. shoot. Let me check again real quick. Oh, I think I know where it is. Hang on. Yeah. Here it is right here. It is a really good shirt. So, like, of course, Lordy has really good taste. Check that out. She's like, I love that this is a shirt that really wants to teach you about sea otters. It is very 90s, but it's just a wealth of information here, you know? It's really good stuff. Primary food sources for sea otters. Really neat. So, it's cool stuff, you know? I haven't worn this shirt yet because it's really tight around the neck. Maybe I can stretch it out. But, yeah. I think it is kind of 90s style. That might be tighter around the neck. But yeah. Anywho. But, some of you might remember that Lordy and I went down to Monterey in late December, visited the Monterey Bay Aquarium, and then I interviewed Scott Benson afterward, expert on leatherback turtles. You remember my interview with Scott, right? Let's find that here. There we go. Yeah. So it was, I think, the day after this.
Out at 1,000 meters. That was as far as those things were able to measure.
So we, of course, did this interview in Monterey, California, and then at one point opened up the blinds so we could actually see. Well, you can't really see it, but Monterey Bay is outside there, including a bunch of sea otters right outside the window. Can't really absolutely collapsed.
Yes.
Yes. Can't really see. Anyway, the day after this, it was the next morning. I had a meeting with Liz McDonald. That's her right there. This was kind of her brainchild, this whole fundraiser for Monterey Bay Aquarium, and I wanted to talk to her about maybe doing some streams with Monterey Bay Aquarium to promote part of their Seafood Watch program, which helps all kinds of different critters, including leatherback turtles. I really need to follow up with her because I've kind of let this just kind of fall off my radar. But I need to send an email to her ASAP because I still want to do some collaborative streams with Monterey Bay Aquarium about leatherback turtle conservation, about their Seafood Watch program. It's important stuff. So anyway, I got the inside scoop from Liz, and it was cool. She's a cool person. Anyway, but yeah, and Monterey Bay is where the game Cyberpunk 2077 takes place. Interesting genre. I can't say I've ever played that. It's a video game, right? It takes place in Monterey Bay? Really? I thought it was like a Blade Runner style environment. Is it like a water game? Yeah. There was a game that I remember from when I was a kid that I thought was really cool. And my little brother was like, huh, Daddy likes a girl game. What was it called? It was for the Nintendo Wii. Endless Ocean is what it was called, apparently. But I thought this was neat. You go around and just kind of explore a marine environment. You hang out with different critters. little text boxes that pop up so you can learn about different marine organisms. It was pretty cool. Anyway, does anybody else remember that? Heard good things about it. Oh, cool, Petrodactylus. Yeah. And Jim is here. Hello, hello, Paleo Jim. I hope you're doing well, Jim. It's good to see you. There may be some Spinosaur news tomorrow that may well blow your mind. Jim, is this Paul Sereno's paper? Is this what he presented on at SVP in Minneapolis? Is that coming out tomorrow? Holy cow. If so, that is very exciting. We've got a new Spinosaur from North Africa with some interesting headgear. Is that what we're talking about, Jim? Anyhow. Border between North and South California. Yeah, Edukdil. That does sound like Monterey Bay. And Jim says, indeed, all right. Oh, boy. I guess tomorrow is going to be partly a Spinosaur stream. I was going to talk a lot about the, about the track site stuff in Florida. Not Florida, Texas. Different southern state with a... Yeah. Yeah. Dinosaur Valley State Park stuff. This big data center project. Oh, boy. We were going to talk about that a lot tomorrow. We probably still will. But it looks like tomorrow might be a big Spinosaur stream, too. Cool. Thank you for the heads up, Jim. I appreciate that. That's good to know. And, oh, I'll take a look at that in a second, Chaotic Kitten. Thank you. But, here. Here we are, talking about California geography. Here's where I live, in the beautiful, sunny San Francisco Bay Area. The Golden Gate Bridge and all of that. That's right here. Here's the Golden Gate Bridge. San Francisco Bay. By some counts, the largest natural harbor in the world is San Francisco Bay.
Spared no expense.
And thank you, Lenina, for gifting Jim. I appreciate that, Lenina. Thank you.
The Lenino gifted 3 months of Tier 1 to Paleo.
3 months? Holy cow, Lenina.
495 months in the channel.
Holy cow, Lenina, do I appreciate that. Thank you. Jim, you won't have to watch any ads here for the next 90 days now? Thank you, Lenina. It's very thoughtful of you. I'm sure Jim appreciates it. Here's the northern border of California, the eastern border, and the southern border. So, San Francisco Bay is here. Monterey Bay is right here. And this is actually where we get a lot of leatherback turtles. This is kind of a hot spot for them. From here up until north of San Francisco up here, this is kind of their summer to autumn feeding grounds. It's right here. And these leatherbacks, they swim all the way across the Pacific from Indonesia and Malay Archipelago, from the Solomon Islands, from over here. They swim all the way to off the coast of California. But anyway, here is Monterey Bay, and so it is kind of the border between southern and northern California. I think folks from Monterey Bay still consider themselves northern Californians for the most part. Just because the concept of Southern California the concept of Central California is not super widespread. Kind of like how we don't have a Middle Cretaceous period. There's just Upper and Lower. You have Northern and Southern California. But I think a lot of people would draw the line south of Fresno for Southern California. But I don't know. Kind of arbitrary, subjective. But yeah. But you got a lot of sharks there as well. It's a good number, Lilithfarten. Yeah. Yeah. Yeah, we've got a fair number of sharks along the California coast. White sharks, leopard sharks, 7 gills, and superfin sharks, and maybe 6 gills too. And a few others. Yeah. Sharks are super cool. Again, go follow Shark Geek if you want to learn more about sharks. That's kind of what he's all about. Yeah. I don't think we get bull sharks. I feel like it's a little too cold for them, Lilithfarten. I don't think bull sharks are well known. We can check real quick. Let me grab my book. This is an excellent one. I'd highly recommend it. It's not only full of accurate information, it's fun to read, too. Sharks, Rays, and Chimeras of California is a really good one by David Ebert. Part of the California Natural History Guides. So, this includes just about every shark that's ever been documented in California waters. There's quite a few. And then other chondrichthyan fishes as well. Like rays and skates. And even chimeras. Ratfish, as they're sometimes called. Yeah. But good stuff. Anyway, most of these are primarily going to be in southern California waters that are warmer. The further north you go, the colder the water gets. But yeah, we get white sharks, especially off the Farallon Islands. And correct, bull sharks are not commonly found there. Thank you, Sharky. Nice to have that confirmation from an expert. I appreciate it. I would have appreciated it equally as much if you'd corrected me if I were wrong. But it's nice to have your input. Yeah, are bull sharks even in here? Kind of doubt it. I think there's a list at the back. That a lot of guides like this have kind of like a checklist. It's like, how many of these have you seen? And, yeah, excellent. Checklist of California chondrichthyans. Chondrichthyans are cartilaginous fish. That's sharks, rays, chimeras, etc. Cow and field sharks, dogfish sharks, angel sharks, horn sharks, mackerel sharks. I kind of doubt they have bull shark in here. Oh, they do! Bull shark. Those are kind of requiem shark. Requiem for a shark. Yeah. Edukdil says, I'll never go swimming in the U.S. I love sharks, but they stay in the water, and I'm not getting close. Fair. You know, water's not for everybody. I get that. But again, you are more likely, just by the numbers, statistically speaking, you are more likely to be killed by a vending machine than you are by a shark. It's a thing. Yeah. More people are killed by vending machines every year than by sharks. Oh, that's dark. New death with indignity law. Lets terminally ill be crushed by falling vending machines. There you go. Anyway. But that is a real thing. You know, we've talked about this before. We have a command for this. There you go. Death by vending machine. It's a real phenomenon. Again, more people are killed by vending machines every year than by sharks. A similar comparison is often drawn to emphasize the rare occurrence of lethal shark attacks or wild bear encounters. There you go. But yeah, this is common enough that they have to put these warnings on vending machines like this. Never rock or tilt, machine can fall over, causing serious injury or death. They should have added extreme dishonor. Serious indignity may result. You know? That's the thing. Being killed by a shark, that's almost like winning the lottery, you know? It's such a rare occurrence. It's like, that really makes you special. This is not an honorable way to die. You know? I'm just processing that people die from vending machines. What? No, that's a real thing, Petrodactylus. It's not a joke. It's as funny as it is. We should not be laughing at it. I don't know if I can find a good video on this, but it is a real thing. The Wikipedia article should be enough. What more do you want, Chad? This is from, well, let's take a look at this from Today I Found Out.
Hello, I'm Simon Whistler. You're watching Today I Found Out, and in the video today, we're looking at whether more people are really killed by vending machines than sharks. Just before we get started, I do want to give a plug to another friend of this channel, which is another video. Sharks, contrary to their fearsome reputation, rarely attack, let alone kill humans. It would seem that they don't deem us suitable prey, though it seemingly has little to do with taste, as is commonly stated.
And Jim says a lot of lives were saved with the invention of flat screen TVs. This is probably true, Jim. Yeah. Except when people try and mount them on the ceiling and then they end up falling directly onto people's heads. But yeah, like giant CRT monitors, giant cathode ray tube monitors. I remember at where my dad worked back in the early 2000s, there was a, holy cow, it was like 5 times bigger than this. Huge TV monitor. Well, like, it was actually a computer monitor, I guess. I used to use it sometimes, but it was way bigger than this. It was probably, I remember it being like 3 times as big, at least. And the thing probably weighed, 600 or 700 pounds. But, yeah. Anyway, Jim makes a good point, that, like, TVs are not as big or heavy as they're not as heavy as they used to be, by virtue of being flat most of the time. Always give me, exactly, Cali Kong, yeah. Yeah, it was a computer monitor. The thing was enormous, Petrodactylus. It was at the company that he worked at back in the early 2000s. It was like one of these huge monitors at the end of a conference room table. So this huge table that you could probably fit 12 chairs on either side of it. And then at the end, this enormous monitor that I remember taking up like the majority of the room on that end. It was huge. Anyhow,
You can find a link to our video, Do Sharks Really Not Like the Taste of Humans, in the description below. But is nature's supposed perfect killing machine really outclassed by humble vending machines when it comes to the number of humans that are killed every year? Despite the contents of vending machines probably killing millions of people over time, when talking about a vending machine directly killing humans, as far as we can tell, most every source claiming that vending machines kill more humans per year than sharks, including our past selves by the way, cite a single report as their source. Now, this report was published by the Consumer Product Safety Commission in 1995, which notably deals exclusively with American deaths via vending machines.
So this is important. Like, this is one of these things that I've repeated again and again, and I feel like it gets, this claim gets a lot of play. People say it a lot. Vending machines kill more people than sharks every year. I had assumed that it was true, but it's nice to check on this,
This comprehensive review of available data states that from 1978 to 1995, a total of 37 Americans were killed by falling vending machines, meaning a little over 2 deaths per year.
Okay. That still sounds like it's more Americans than are killed by sharks every year. Let's see.
As a result of this data, warning labels began adorning most vending machines, cautioning consumers that rocking or tilting a vending machine may cause it to dole out death instead of Twinkies, although the label probably actually said something different. Since that time, the statistic has been quoted across the news and internet and is often extrapolated upon to suggest that the odds of being killed by a vending machine anywhere in the world is more than being killed by a shark, despite the report only dealing in American deaths. Now, on the one hand, it is true that during that span discussed, at least statistically, Americans were more likely to be killed by vending machines than sharks, because on average, slightly less than 1 American every year was killed by a shark. But there are a number of problems with this comparison. First, someone sitting in the middle of Oklahoma has 0 chance of being killed by a shark.
I wouldn't say 0 chance. I bet you there are fossil sharks from Oklahoma, and there's a chance that you could, one of those could fall on you, or if you're a hemophiliac, maybe you accidentally run your hand over the teeth, and then you're in the museum late at night, and you bleed out because the phones aren't working or something. I don't know. Like, 0 that's a strong claim, A non-zero chance doesn't mean it's a likely chance. Doesn't mean that's a big number, but it's, all non-negative numbers are greater than 0,
in any given moment, or 0 for their entire lives if they never travel to the ocean or fall into an aquarium shark tank. This means that the 1 in 400 million statistic that you often hear is not actually correct for them. Likewise, the Floridian, who regularly surfs at the beach, has greater odds of dying from a shark attack than the stated average, though they are still amazingly low odds. Specifically, one's exposure to, and specific chosen interaction with, vending machines further muddies the water here. Some people almost never use them, and others use them daily. Even for those that use them regularly, if they aren't physically strong enough to rock the vending machine, which is why, by the way, it's amazingly rare for women and children to die this way, the odds
it's
of
always
death
men. Yeah, so that's part of the article here is, here we go. Pull up that link again. The vast majority of injuries and deaths have happened to men. Unsurprising, maybe. It's kind of like how literally every single one of the mammoths who fell into the sinkhole and died and were preserved at the mammoth site in Hot Springs, South Dakota, they're all young male mammoths. Just up to no good. Every maybe few decades or something like that, one would fall in. They're all males. Oh, yeah, hashtag not all men. Yeah. My odds of vending machine death looking pretty good. There you go, Petrodactylus. Yeah. Anyway, again, I feel like it would be a far more dignified death to die at the jaws of a shark than, under the mass of a vending machine. Kid mammoth. Yo, check this out. Hold my mammoth beer. You sure it wasn't a mammoth sacrifice pit? I mean, that's an interesting idea, Red Cherry Pie. Anywho. Yeah. Anyway, sharks get a bad rap. That's the whole point that I'm trying to make here. And vending machines have been legitimately deadly to a lot of people. You know, it's a creature that has never caused the death of a person, at least to my knowledge, but can weigh roughly the same as a vending machine. Does anybody know what I'm talking about here? Should we pull up our leatherback turtle video in Japanese that I did my best to translate, despite not speaking or understanding Japanese? I thought I'd try my hand at translating this anyway. Would you like to see it, chat? It's got vending machines in it. Here. Take a look.
オサガメは太平洋や大西洋、インド洋に地中海などいろんなところに住むウミガメの仲間で、日本でも時々見つかったりすることがあります。大きさは大きいものだと2メートル以上、重さ500キロ以上と、身近なものだと自動販売機と同じくらいのウミガメどころか今生きているカメの中では一番大きい、すごいでかいカメです。しかも、一番は大きさだけでなく、泳ぐ速さもウミガメで一番速くて、潜る深さも1000メートル以上と、これまた一番深くて、泳ぐ距離も1万2000キロと、記録尽くしのとんでもないカメだったりします。そんなオサガメは、見た目が非常に特徴的で、形は、上から見ると他のカメに比べて細長い流線形で、頭からお尻の方にかけてケールがある。モーターボートをひっくり返したような形になっていて、それのおかげで水の抵抗が少なく早く泳げるのではと考えられています。そしてもう一つ、見た目の大きな特徴として、他のカメのような硬い甲羅がないっていうのもあります。オサガメの甲羅は、細かい骨が集まってアスファルト舗装されたみたいになった上を皮膚が覆っていて、硬いゴムのような弾力性を持っています。この弾力性のおかげで水深1000メートル以上潜っても水圧に耐えることができるというわけです。ちなみに、こういった特徴から、オサガメは英語だとレザーバックタートルもしくはレザーバックシータートルって言いますが、
On formal occasions, he's called Brontosaurus. Big fella, isn't he? 70 feet long. Tips the scales at a substantial 35 tons.
Milton T. Pike, thank you so much for the follow and for your message. Holy cow. Fun fact, I wrote my graduate thesis on the leatherback turtle, Dermachelys coriacea, specifically their temperature-dependent sex determination and how it's being affected by climate change. That is incredibly cool, Milton T. Pike. This is an animal that I have been obsessed with for the better part of a year now, and I'm starting to get involved with leatherback turtle research and conservation. Holy moly. Here. Awesome. I don't know how recently you just joined the stream, but I did an interview with Scott Benson, leatherback turtle researcher here in California, back in December. And then I did an interview with Jeanette Wyneken, who I think she does a lot of work on...
Sub to Milton T. Pike 1. They have given 531 gift subs.
Holy cow, Golganek. I appreciate that. Thank you, thank you. Yeah, I did a stream with Jeanette Wyneken just a little while ago. Here we go. And we talked a lot about temperature-dependent sex determination. Their lives. Like, right after they hatch, they're doing that. It's kind of integral to their ecology. It's really interesting. Are they doing that to evade predators, you think? Because they're not finding food at that sort of depth, are they?
Well, no, when they're hatchlings, no, they're still got that belly full of yolk.
Let me find the...
certainly
different predators.
We're talking about temperature.
You know, if you're down kicking up sand on the bottom, you might
now.
wake up a triggerfish or something.
Sure.
And triggerfish may have a small mouth, but it's a very sharp one. So, information is about temperature dependent sex determination.
Right.
Animals do not have sex chromosomes, and so there's got to be another mechanism by which.
Just got here maybe 5 minutes ago. Holy cow, Milton!
So, one of the mechanism that most turtles have is what we would call hot chicks, cool dudes.
Right.
And
Let me give you a follow real quick.
Warmer temperatures produce warmer incubation temperatures produce females, and cooler or less warm.
Come on now.
In South Florida, so it's warm and less.
259,000 followers. Holy cow!
Can produce
Excellent.
males. And I wouldn't say we produce a lot of males, but there are areas that do produce some males. Thank goodness. We're seeing fewer and fewer of them, but that's a different part of the story. But anyway, that people.
Awesome. Thanks for following. You bet, Milton. Yeah. Holy cow. Do you since your PhD, have you or was it a master's? Have you worked on Dermachelid turtles since then? You seem like a good person to know. Little Pink Pony says Milton is good people. Evidently. Yeah, holy cow. He streams with Kit Boga sometimes. That's awesome. Okay. Yeah, leatherback turtles have been an obsession of mine since this past May. I got to go on a trip to investigate some family history stuff in Puerto Rico. And holy cow, there were leatherback turtle nests at pretty much every beach that I was able to visit. It was bonkers. So here we go. This is in Luquillo, in kind of near San Juan, northern Puerto Rico. I'm presuming this is a leatherback nest just based on sheer size of the area that's roped off. But these are animals that I've been reading about since I was a little kid, you know? Every dinosaur paleontologist is at least dimly aware that there is this incredible animal that still plies the world's oceans that can trace its origins back to the Cretaceous. It's a critter straight out of the Mesozoic, and it is still around today. These are absolutely astonishing animals, and now that I've got some semblance of a platform here on Twitch, some kind of megaphone, I wanted to use that to try and raise awareness about these animals, aid in their research and conservation. So this has been a big project for us for 2026. Yeah. And they are crazy. They're one of the most unique vertebrate animals on the planet. They really are, you know? Yeah. And Milton says it was just a master's. Not just a master's. That's still really cool. And you ready for the craziest pivot? I ended up redirecting my entire thesis to the epistemology of evaluative practice in environmental science. I was basically comparing an analysis of how the researchers actually reached their claims. No, that's really cool. Milton, are you familiar with Rhaekodactylus here on Twitch? He studies, like, philosophy of science, cognitive science, kind of verging on, like, sociology and stuff, but I feel like you two might have some interesting conversations about that. That sounds like it's right up his alley. But yeah, we're going to raid into him at the end of today's stream, I think. He's normally a speedrunner here on Twitch, but he does science outreach streams on Wednesdays. So he puts on his cognitive scientist hat on Wednesdays, and we like to raid in on Wednesdays as a result. Stream about oh, there you go, Cacklin's Roof, yeah. Yeah, awesome. Anywho, Milton Pike, I appreciate you. Small world, right? Holy cow. But yeah. And thank you for the 5 gift subs there. Milton, you did not have to do that. I really appreciate it.
Milton T. Pike 1 is getting serious with
Holy
those
cow.
5 gift subs.
Phenomenal. Thank you for your generosity there. It's 5 lucky chatters who won't have to worry about seeing a single ad for the next month, thanks to you, Milton. I really appreciate that. And not to dox anybody, I might be seeing some of your papers here on Google Scholar. Maybe not. I don't know if the first and middle initial match up. But anyhow, yeah. Love a good science chat, and you seem like an exceptional individual. Oh, goodness, Milton, you flatter me. Here, I should play a quick little channel trailer to introduce you and any other new folks to what we're all about here on Paleontologizing. Here we go. This is me.
My name is Danny Anduz. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs. A limb bone from a new duck-billed dinosaur. I invite you to tune in and experience the adventure of fossil science. There we go. I had to put that video together for when they wanted to make me a Twitch ambassador back in October, which is what's happened now. So I decided to use it for a channel trailer too. I need to make some more because it feels a little repetitive showing that multiple times in a stream when new people show up. But anywho, yeah, Milton, wonderful to meet you. Holy cow, small world. And looks like you didn't publish your stuff, but it sounds like it was really important. Did you work with Jeanette Weineken at all, possibly? I'm hoping to go visit her lab sometime in late May, and hopefully do some streams from there. Maybe do some fundraising for her program. And I'm looking to hopefully link up with some other marine turtle people, and maybe even do some surprise late night streams from some nesting beaches. You know, with leatherback turtles. We'll see. I'm still in the let's figure out what's possible stage here. But yeah. Love to hear the results of that visit. Yeah. Cross your fingers that it works out. Yeah. Anywho. Good stuff. Blittiness says, I'm so ready for the field streams in a few months. I'm looking forward to that, too. I'm going to be in Wyoming, and I'm going to be in Utah, and I have to look into maybe doing some Montana field work as well this year for the first time. For the first time on stream. I worked in Montana for years and years, long before I was on Twitch. But, yeah. Anywho. And thank you, Milton. Hey, I appreciate you. Thanks for being here. Thank you for the gift subs. And can we get another shout out for Milton T. Pike? I'd appreciate that, and I bet he would too. Everybody go follow Milton T. Pike if you haven't yet, like I just did. And last played some Grand Theft Auto V. That's the 5th one, right? Nice. Good stuff. Appreciate you, Milton. Thanks for stopping by. We have got some fossil news to discuss today. We haven't even gotten into that yet. We've already been streaming for what? Close to 2 hours now at this point? 3 hours at this point? Without further ado, let's jump into some fossil news here. Let's play the video stinger. All right, so this is pretty cool, and I didn't know this was coming out. I hadn't heard about this at any conferences or anything leading up to this. It was a surprise to me. But features one of my favorite dinosaurs. Triceratops has a special place in my heart because I've dug up a lot of Triceratops over the years, working with Denver Fowler and John Scannella. I'd probably worked at maybe close to 30 or 40 different Triceratops sites over about 8 years in the Hell Creek Formation. So yeah. Triceratops' oversized nasal cavities played roles far beyond smell, paleontologists find. For decades, depictions of Triceratops and its kin have been driven by bone alone. Now, paleontologists in Japan have mapped out the soft tissue anatomy of these horned dinosaurs, revealing unexpected structures that may explain how they regulated temperature and breathed. This is really cool. So Triceratops has an enormous nares. This is the bony nostril here. We've known about this since the late 1800s, when Othniel Charles Marsh first described Triceratops. Let's find a 3D model of this critter to talk about. There we are. That'll work. This is a slightly wonky mount here. I feel like the forelimbs are mounted kind of high up. I don't know if they actually had gastralia like this. I don't know if we really have evidence of that, of belly ribs in ornithischian dinosaurs like Triceratops. But anyway, big ol' nares here. That bony nostril is enormous. We think that the fleshy part of the nostril would have been right here, but there's all of this open space, and like, what is the deal with that? Maybe I can find you a better model that's that'll work. Triceratops skull here. For storing snacks, says Toilet Gator. Interesting hypothesis, but we'll see if it holds up. It is kind of a mystery, like what's going on with that big ol' opening there, you know? Why have such a big open space here if your fleshy nostril is probably just like right here? Why have that? Well, a team from Japan is trying to figure this out. Horned dinosaurs, Ceratopsia, including the iconic Triceratops, were among the most diverse and successful dinosaur groups of the late Cretaceous. At least in the northern continents, they are. Down south, they're not so common or widespread. In fact, they seem to be mostly or entirely absent. But North America, Asia, and now we realize, as of like last month, Europe. There's ceratopsians all over the place. Horned dinosaurs galore. Their skulls rank as some of the most elaborate ever produced by vertebrate evolution. Or invertebrate evolution, for that matter. Invertebrates tend not to have skulls at all. So you could have just said animals. Their skulls rank as some of the most elaborate ever produced by any animal, combining the beak, a variety of horns and frills, an expanded nasal region, and a tightly packed dental battery. Lots of teeth and this continual, like, cutting, grinding surface, built for processing tough vegetation. But because these distinctive features likely underpinned the group's ecological dominance on land, scientists have long focused on the functions of their cranial structures, particularly the horns, beak, and frill. By contrast, the biological significance of their enlarged nasal region has remained mostly unexamined. I have been working on the evolution of reptilian heads and noses since my master's degree, said Dr. Saishiro Tada, paleontologist at the University of Tokyo Museum. Triceratops in particular had a very large and unusual nose, and I couldn't figure out how the organs fit within it, even though I remember the basic patterns of reptiles. That made me interested in their nasal anatomy and its function and evolution. In the new study, Dr. Tada and his colleagues examined several cranial specimens of Triceratops, so they looked at a bunch of skulls. Employing X-ray-based CT data of Triceratops, as well as knowledge on contemporary reptilian snout morphology, we found some unique characteristics in the nose and provide the first comprehensive hypothesis on the soft tissue anatomy in horned dinosaurs, Dr. Tada said. This is exciting. I wonder if they looked at any of the Triceratops specimens that I helped dig up for Museum of the Rockies in Montana. We'll look at the paper and we'll see which specimens they figure, but there's a chance that some of my Triceratops made their way into this study. Triceratops had unusual wiring in their noses. Wiring in, not quotation marks, but whatever the singular ones are. In most reptiles, nerves and blood vessels reach the nostrils from the jaw and the nose, but in Triceratops, the skull shape blocks the jaw route, so nerves and vessels take the nasal branch. Interesting. So it's jam-packed with nerves that go in other places in other animals. Essentially, Triceratops' tissues evolved this way to support its big nose. I came to realize this while piecing together some 3D printed Triceratops skull pieces. Like a puzzle. Very cool. Another parallel to what we do here. All of our 3D printing of different dinosaur elements. Like here's a Triceratops brow horn that I have here on the wall today. This was printed life-size. It's scanned from an original Triceratops brow horn. But this is a small one from a young individual. But this is the brow horn. It's one of the ones that goes up from the eye. So this is going to be the left brow horn. So on this side. Yeah. There we go. The researchers also identified a specialized structure in Triceratops' nose, known as a respiratory turbinate. This is exciting. This is something that's been long hypothesized in dinosaurs. It was kind of an argument for why dinosaurs couldn't be warm-blooded, because, well, warm-blooded animals, like mammals and birds, they have respiratory turbinates in their noses. And so dinosaurs didn't have this, so they couldn't have been warm-blooded. Well, now we might have evidence for that in a dinosaur, finally. Yeah, nasal turbinates, this is something that we have as human beings. So inside of our noses are these soft tissue structures that help warm and moisten the air that we take in through our noses. Critters like dogs have this too. And here it is in is that a seal skull? What is this? You see this in a bunch of different organisms. The nasal turbinates. Do you have a video on this? Oh, it's an otter. Okay. Well, back to our sea otters. Excellent.
This is actually going to be the nose of the sea otter. And inside that nose is a huge maze of little bony structures that are
Yep, there you go. The nasal turbinates.
called turbinates. So having a very intense labyrinth or maze of turbinates allows for more area to humidify that air and warm it as it's coming into the body.
And I believe that also functions like that with humans as well. Nasal turbinates look quite different in the sea otter skulls versus our human skulls. So the 3 nasal turbinates that you see here assist in smelling, breathing, as well as humidifying the air, and it also helps aid in our immune response. They are much more elaborate though, as I can see here in the sea otter skull.
Sea otters also live in the ocean, which is saltwater, and they are not adapted to drink salt water. They still need fresh water. So if they're breathing in air and like humidifying that air, they're able to absorb every ounce of water from it as possible with these really intense turbinates.
Cool. And this is not just something that humans and sea otters have. This is fairly common with many mammals and animals living up in these colder climates. Musk ox and caribou
Yep, they actually have
very
spiraled ones.
Yeah, very complex ones as well. So amazing how many animals can live up in this cold environment.
Yeah, and really thrive in it too.
Pretty cool. So this isn't necessarily something for cold environments, always, but it certainly does help with that. Here's a link to this video here. There we go. So nasal turbinates, or respiratory turbinates, as they're termed here, an anatomical feature almost unknown among other dinosaurs, but common in their living descendants, birds, as well as in mammals. These thin, curled nasal surfaces increase the contact area between air and blood, helping regulate temperature through heat exchange. Triceratops probably wasn't fully warm-blooded, and I do wonder about that. I lean more toward thinking of pretty much all dinosaurs as being more or less endothermic, warm-blooded, generating their own body heat by burning calories. But there is some evidence that maybe ornithischian dinosaurs in general, your beaky plant-eating dinosaurs, they may have had lower metabolisms than their sauropod and theropod cousins, including birds. But I don't know. Anyway, this press release says Triceratops probably wasn't fully warm-blooded, but the scientists think that these structures helped keep temperatures and moisture levels under control, as its large skull would have been difficult to cool down otherwise. Although we're not 100% sure that Triceratops had a respiratory turbinate, as most other dinosaurs don't have evidence for them. And again, it might just be that they are difficult to fossilize, you know? Some birds have an attachment base or ridge for the respiratory turbinate, and horned dinosaurs have a similar ridge at a similar location in their nose as well, Dr. Tata said. That's why we conclude that they have the respiratory turbinate as birds do. Horned dinosaurs were the last group to have soft tissues from their heads subject to our kind of investigation, so our research has filled that final piece of that dinosaur-shaped puzzle. I do suspect that a lot of other dinosaurs would have had nasal turbinates or something similar. We have evidence in armored dinosaurs. Critters like Mongolian ankylosaurs, that they would have had pretty elaborate labyrinths in their nasal passages. That would have acted a lot like nasal turbinates. You know, like an ampersand or a crazy straw in their head that would have helped maybe moisten the air as it's coming in, because a lot of these guys lived in very dry desert environments. It may have also had something to do with producing sounds. Maybe this is kind of like a woodwind instrument. They could exhale through their nose and produce far-out noises. Who knows? But yeah. Anywho. Murph says, how big until you become a gigantotherm and are naturally warmer? That's a good question, Murph. We don't really... These terms are not the best defined. If there's anything I've learned by reading about and discussing leatherback turtle metabolism, it's that these are kind of poorly defined categories. Like anytime we have something that's kind of an edge case, this whole dichotomy between ectotherm and endotherm, and then gigantotherm or mesotherm or poikilotherm and homothermy. These categories are squishier around the edges than we would like to admit most of the time. So I don't know. Could big ornithischian dinosaurs maintain their body heat just by virtue of being large without having to burn too many calories? I don't know. You know? It's a good question, Murph, as usual. And Murph says gigantothermy is mostly just surface area bigger unless you are less. Yeah. Well, that's the thing, Murph. Is there are not. As I understand it, gigantothermy is one of these things that's kind of squishy in its definitions, largely because we don't really have many animals today that we could call gigantotherms. Maybe critters like saltwater crocs or leatherbacks. But most of the big animals that we have today are mammals. And so they already have a certain degree of endothermy. So we don't really have a lot of examples of critters that could possibly be gigantotherms to study, you know? So I feel like it's one of these things where, like, it sounds good on paper, it's an interesting idea, but, like, do we have any examples that we can really study today? Leatherback turtles you would think would fit the bill, but there's a couple researchers I really want to interview about this to get a better sense for what to call these critters, you know? I tried to do that with Jeanette Weineken, and I should have probably asked the question in a more precise way. That's not this stream. Hang on. Where was that? Here we go.
That people will say, well, why don't you just heat up the water or cool down the water?
Transcript. Let's do a Control F for metabolism here. What's the transcript goes? There we go. Probably close to being warm-blooded. Birds evolved from dinosaurs. That's probably where they got their endothermy from.
Yeah.
But leatherback turtles kind of almost defy categorization when it comes to metabolism.
I
Yeah,
agree with that.
can you walk us through that a little bit?
Well, all right. So when we think about, you know, the idea of heterothermy, that just means that the body temperature varies. And
Yep.
Homeothermy, it means it doesn't. So we're homeotherm.
Constant, yeah.
Your dog and cat are homeotherms. Or, you know, so endothermy is generating your heat from within. So
Right.
leatherbacks are sort of endothermic when they're adults. So that
Sort of warm-blooded, I guess, is the term that people in the audience would be most familiar with. Yeah, yeah.
when they're you know, when that blubber layer is there, when they've got their muscles are big, and you know, we all know that if we, you know, if you're cold, go exercise, go run down the street or jump rope, or if you really want to, you know, warm yourself up, do something with your big muscles, you know, the muscles in your legs.
Right.
And so we all kind of have some feeling about that it, you know, muscles generate heat, and they do. And with leatherbacks, you know, that ability to kind of trap that heat inside is works great as long as they're big enough. But in these little guys, the little ones, they're not that big. You know, you know, when we bring them in the lab, they fit in the palm of my hand.
Yeah.
And by the time we release them, they still fit in my hand, but it takes the whole hand. And
Here's
so
the size of a hatchling right here.
those
Hatchling
animals are,
leatherback.
you know, the temperature of the water. So you know, they're, you know, if they're hanging out at the surface, they're a black turtle, so they're gonna heat up.
Sure, they're getting that solar radiation and warming up
Yeah.
from that.
Yeah. But yeah, there's a limit to that idea of
Right.
endothermy. So they yes, if a little leatherback is swimming, its muscles are heating up, but it doesn't have enough insulation. It doesn't have enough body volume to trap much heat. And whereas the surface area, it's that kind of classic thing that for those people who've gone to a biology class or a physics class, or you learn the surface to volume ratio idea. And as you get to be a bigger surface, you have more volume. You have a greater volume, and so when you're a smaller animal, your surface to volume ratio is not hugely different. It's different, but it's your volume is always going to be bigger than your surface, but not by as much as you would expect, or might, without thinking about it and doing a back of the envelope calculation. So anyway, that that component of their life is endothermic. Are they endothermic? Part of the time they are. Are they endothermic? Certainly when they're young. That's probably why we don't see them in really cold waters for any length of time. And and if we get a leatherback stranding, a young turtle stranding, it's usually during the part of the year when the waters are cooler, and so. Yeah,
do you get that in Florida? Are there leatherback strandings due to cold?
Yeah, occasionally. Well, not so much cold stunnings as like if they get a little leatherback stranding, it's almost always going to be in December or January. If we get when I say little leatherback, something like this big, opposed to this big, or more than I can.
Anyway, so again, I hope this serves to emphasize the point that, like, these terms that we have, endotherm versus ectotherm versus gigantotherm versus mesotherm versus whatever, these terms almost kind of fall apart when we try and apply them to leatherback turtles, because this is a critter that kind of runs the gamut here. When they are little hatchlings like that, they are ectothermic. They have to rely on the surrounding temperature to heat their bodies. But when they're full-grown adults, when they've got those big muscles, high levels of activity, they can swim in water that there's icebergs floating in, Leatherback turtles, adults, have been spotted as far north as like the Aleutian Islands off of Alaska, or off the northern coast of Norway, up in the North Sea, as far south as like the southern islands of New Zealand, or like down near Tierra del Fuego, southern Argentina and Chile. It's remarkable. Like in water that's barely higher than freezing temperature, we've got a turtle swimming around. Is it truly generating its own body heat by burning calories? I mean, it is, but in the sense that it's moving its muscles to generate heat. Do we call that endothermy? Like, it is producing heat from within its body, so I guess you could, but again, it's tricky, Our feeble attempts at categorizing the mighty leatherback turtle, those attempts kind of fall flat. It's a critter that kind of defies categorization, and that's one of the reasons why I think it's so fascinating, But yeah. And Ms. Ardul says, are there any dinosaurs that have their metabolism that sped up or fast? Yeah, so we do have good evidence that at least some, if not most, if not all dinosaurs could generate their own body temperature. When we're talking about metabolism, like, it's hard oftentimes to figure out whether an extinct animal was warm or cold-blooded, if it's part of a group that doesn't have living representatives. If you find a fossil crocodile, for instance, a crocodiliform, a fossil croc, you can look at this critter and go, okay, it's a croc. we look at them today and we go, well, you know, these animals are ectothermic. They have to rely on outside sources of heat to warm their bodies. It's easy enough to say for this animal, because there are living representatives of this group. But if you're looking at something like, I don't know, Heterodontosaurus, right here. This is a smallish dinosaur. Its skull is about this big. In fact, I have a heteroskull right over here. Oh, there we go. That's not a particularly big animal. So it's certainly not a gigantotherm. Were these guys warm or cold-blooded? A lot of it will come down to, well, there are various ways that we can try and figure this out. You can cut the bones open and look at the growth rings to figure out how fast they were growing. That can be an indicator of metabolism. A very fast growing animal is, chances are it might be generating its own body heat. It's got a, you know, elevated metabolism. You can look at things like their integument. Do they have scaly skin like this? Or did they have some kind of insulation over their bodies? Were they fuzzy? Did they have insulation to keep in body heat that they're generating themselves? There's another member of this same family called Tian Yulong. And these guys, we do have evidence of some kind of bristly, fuzzy covering on them. So that is an indicator that they may well have been warm-blooded. Cold-blooded, ectothermic animals tend not to have any kind of insulation like that, you know? You don't see feathers or fur or fuzz on lizards or snakes. So this is an indication that these animals probably were more or less warm-blooded, you know? We think. It's not necessarily a smoking gun, you know? It's because dinosaurs tend to be so different from other living creatures today, except for birds, who are dinosaurs, that it gets kind of tricky, you know? Mr. Photography, how are you doing? Welcome to Paleontologizing. I think I saw your follow a little while ago, a couple days ago maybe? Welcome, welcome, Mr. Photographer. Good to have you. Shark Geek says, I've never seen fossils of the bony croc plates like that before. Yeah, the osteoderms. It is super cool. Yeah. So with some crocs, if they're very well preserved, and if they're, you know, fossilized in articulation, not only are all the bones in place, but those bony armored scutes, what we call osteoderms, are also preserved in place. They're really cool and very distinctive looking. So here's Deinosuchus. This is a reconstruction, but it helps to illustrate those scutes, what they look like there. Just like on an ankylosaur, these bony armor plates are kind of embedded inside the skin. So they're not connected to the other bones. They're part of this, like, skin bone armor that these animals have. Here we go. Here is well, here's what they look like up close. These little osteoderms. There's an American crocodile and an American alligator, left and right, respectively. Yeah, here's a really cool mount of a Nile crocodile with the osteoderms placed as in life. Super neat. It's you don't often see this in a museum because it's so much work to place all the osteoderms there, because each one has to have a little holder for it. It's an incredible amount of work. So we got to see this firsthand when we went to visit Rob Gaston's workshop a couple years back. I'll find that VOD for you. His Scutellosaurus mount is a sight to behold. There we go.
Okay.
Early 70s.
Okay,
actually.
so this was an animal that was found roughly 40 years ago. Little creature, but what's incredibly important about this animal is that it's one of the earliest armored dinosaurs. And when things are this small, you just don't get them preserved, period, let alone with a nice set of armor. Now, having said that, all the armor that you see, a lot of this was restored, although there were over 100 pieces of armor. So this came from the Navajo Reservation in northern Arizona. And we had most of the internal skeleton for this, so there's not a lot of guesswork in what...
I want you, Chad, to appreciate the incredible amount of work that this took to place each of those osteoderms on their own little armatures on this skeleton. Like, this is incredible that Rob Gaston did this. Just incredibly time-consuming.
You know, the proportions of the animal, what it looks like. What is guesswork is we don't know what the armor looks like. I mean, we don't know the arrangement of it. And these guys probably had really complex alternating rows of armor in different, high-profile armor, low-profile armor, different places on the body. Almost impossible to know what that arrangement was. But we can look at later animals that give us a little bit of a clue, but it's still a guess. And so right now, this is our first kind of working model of what we think it may have looked like.
This is so cool.
I feel confident that it's correct in the sense that it was probably covered with armor, and we know these are a lot of the shapes that it had because they were preserved, they were with the skeleton, but we just don't know exactly, maybe these go further back, maybe they go further forward, maybe on the tail, maybe there's a lot we just don't know about the arrangements.
It's an incredible amount of work that clearly went into this. I mean, I hope you can see, chat, here how each of these osteoderms, these little armor plates on here, are suspended above the rest of the skeleton. It's not like they're actually attached to the bones. Each one of these has got a little bit of wire kind of removing it from the bones a little bit, because those osteoderms were embedded in the skin in life.
Yeah, so exactly. They would have floated in the skin like a crocodile or an alligator.
How long did this take, Rob?
Well, it took longer than it looks, so...
longer than it is.
Probably, and so... we've got to go through all the process of molding, casting, painting. So once everything is quote, done meaning you've got a box of pieces that are all colored and painted and ready to put together, then it's about a week, 6-7 day process, about 3 to 4 solid days just to put the armor on, another 2 or 3 days to put the skeletal elements underneath together. So it's a lot of work.
Anyway, crazy to think about, I'll give you a link to that VOD with a timestamp there. And oh yeah, it took millions of years to evolve, obviously, Claire. Yeah. But anyway, it gives you a new appreciation for stuff like this. Putting all the osteoderms onto a mount of a croc like that. Which is why most of them that you'll see in museums don't even have the osteoderms. This is neat because it actually, I guess they preserved the skin there with the osteoderms inside the skin for this mount. That's a really neat one. But yeah, pretty awesome, these critters. Osteoderms are they're fascinating. They really are. So the next time you see an alligator or a crocodile or a caiman or a gharial, look at those bumps on the back and realize, oh shoot, those are bits of bony armor.
We have much to learn about the age of reptiles.
And we certainly do, Sergio. Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Anyway, let's get back to our Triceratops article. Next, says Dr. Tata. I would like to tackle questions around the anatomy and function of other regions of their skulls, like their characteristic frills. Team's paper is published in the journal Anatomical Record. Here's a link to this press release here. We're going to take a look at the actual paper. And if you have any other questions about Triceratops and what's going on with their heads, let me know. I'm guessing they were working on Triceratops prorsus from the upper Hell Creek, given that that's the species illustrated here. But let's take a look at that paper, which thankfully is open access. No paywall on this. So here is a link for you there in the chat.
Access granted.
There we go. And this is in the journal The Anatomical Record, which is, I would say, despite being kind of a smaller journal, well respected. People have good things to say about AR, Anatomical Record. And Heather Smith, who I think might be lead editor for the journal, she's somebody I want to interview in the nearish future about the fossil history of sea turtles, including leatherbacks. But anyway, cool journal, Anatomical Record. And this is absolutely like part of their wheelhouse, figuring out the anatomy of extinct critters by using modern animals as an example. Yeah. The Anatomical Record. They had a neat illustration with some ancient crocky guys here not too long ago. Where was that? They were handing out stickers at a conference I was at not too long ago. 2023. I don't know if we'll find it here. Oh, was it here? Yeah, that's the one I was looking for. Nice. So here is the illustration on the cover of that journal. This was October 2022. So we got various species of crocky guy here. Land-living crocs and aquatic crocs. And then here is a breakdown looking at some of their anatomy. Their major muscle groups in their limbs, nerves in the skull, digestive organs here, hind limb and tail musculature. Really cool. So again, this is the sort of thing that's, yeah, Anatomical Record is all about. Yeah, isn't that neat? Here, I'll give you a link to that Petrodactylus, because it is a really rad illustration. Super cool. It's a neat journal, Anatomical Record. Different scientific journals will have kind of different specialties. It'll be like, we really like this kind of research or that kind of research. We might have an editorial staff that's specialized in something like this, and we know a lot of people who are good at peer reviews for this sort of topic. So like when you're publishing some of your research in a scientific journal, you kind of have to pick the right journal to submit your research to. And certain journals will be like, yeah, this looks cool, but this is outside of our wheelhouse. So we're going to reject this. Go shop it around to other journals, you know? It's not a good fit for our journal. But this seems to be a very good fit for Anatomical Record. Yeah. Make this my phone background. It's very cool, Petrodactylus, yeah. And I got... Here, let me see if I can find it. But they gave me a sticker of this a while ago. I think I know exactly where it is. There. It's in my bag of stickers here. Yeah, there it is. Lovely. Here we go. How cool is that? Yeah. What a neat illustration. Super cool. Yeah. Yeah. Petrodactylus, if you were to write to Heather Smith or some other folks from that journal, if they have any stickers left, they might even be kind enough to mail you one. If you really like that image, something to think about. How are you doing, Mini Pie? You're trying to navigate this labyrinth of scissor arms here? How you doing? Well, my landlords has shown up. How you doing, Mini Pie? Hi. Yeah. Good stuff. Yeah, but they were giving out those stickers for free at MTE 14, the 14th Mesozoic Terrestrial Ecosystems Conference, which was held in Salt Lake City back in 2023. It was one of those times when I didn't stream for like almost a week, I think. I was busy presenting at this conference and attending different talks and poster sessions and stuff like that. It was great. It was one of the better conferences I've been to in a while. It's, How are you doing, Mini Pie? What's shaking with you? Oh, here, okay, I'll get you some treats. Time to pay the landlord here. Yeah. There we go. Look at those. Good stuff. Yeah. That's the good stuff. Excellent. And we're a quarter of the way to our sub goal. Excellent. Wait, how did that happen? Thank you, Neverwinter. I appreciate it. I think the alert is taking a minute here. Look, there's all these crumbs. You can eat those. Clean up your mess. Clean Plate Club, Mini Pie. Clean Plate Club. Look at that. What's in these? That's it? I guess that's all she wanted there. What are you doing, Minnie? She's just bored. What's going on? Alright. Gotta clean up all this cat saliva and crumbs off my desk. But yeah. Yeah. And hey, Kiradorian, good to have you here. We're about to jump into this this paper. Blah. About Triceratops nasal soft tissue anatomy. Exciting stuff. And Otter Do It, how are you? Oh man, Otter Do It, you missed some of our Otter stuff today earlier. You should check out the earlier part of our VOD. But it's good to have you here, Otter Do It. I hope you're doing well. Let's clean this up. And holy cow, what is this? Call me Lucy. Thank you. Those 20 gift subs.
Gifted 20 subs.
Holy cow, Lucy. Amazing. Thank you for your generosity there. Holy moly. Not only are you bringing us up closer to our sub goal, we've got one more day to try and get to our sub goal for the week. But now there's 20 chatters who won't have to worry about a single ad for the next month thanks to your generosity. and you're supporting science outreach here on Twitch. You're helping me pay the bills. That's a big deal. I really appreciate it, Lucy. Thank you, thank you. Appreciate the support. I know those chatters did too. Excellent. Helping me afford paper towels so I can clean up this mess that the cats make. I will be right back. There we go. Okay. Sorry, that took a minute because I was also restarting the 3D printer. That leatherback bobblehead has finished printing. So I just set it going with a second one. I might as well, you know? Alright, cool. Good stuff. Again, I appreciate you, Lucy. Thank you for the 20 gift subs. Excellent. Printer's still heating up. It'll go in a minute. Let's dive into our paper here. Nasal soft tissue anatomy of Triceratops and other horned dinosaurs. Interesting. Again, I wonder if they're going to be looking at any of the Triceratops specimens I've helped dig up over the years. I'm sure they're going to be looking at some privately purchased specimens, given that these researchers all seem to be from Japan. Tokyo, Ibaraki, Tokyo, Kagoshima, Chiba, Fukui Prefecture, Fukui, yeah. Anyhow. Oh, but they've got an AM&H specimen, at least. Drexel University, Burpee Museum. Oh! Look right there. Museum of the Rockies in Bozeman, Montana. That's where I used to work. I bet you they looked at some of the Triceratops that I helped dig up. We'll see. We'll see. There is a brow horn and nasal horn of a Triceratops. Just like the brow horn that we have right here on our wall today. There's the orbit, the eye socket right there. And yeah, there we go. There's the rostrum, maxilla, nasals. Yeah, good stuff. Anyway, so they're trying to figure out the nose on this critter and what it's all about. There's a Yale Peabody Museum specimen there. Let's see some MOR specimens, maybe some of the ones that I helped dig up. Let's see. Here they're mapping out where the different nerves would have gone based on the kind of the detailed morphology of these different skull bones. Different muscles and nerves and blood vessels and things like that will actually leave marks on the bones. And we can use this, we can kind of ground truth this with modern animals. So when you're doing a dissection of a modern animal, if you pay really close attention to the different muscles, the different nerves, the different blood vessels, you see that they often fit into different grooves and stuff on the surface of the bone. We can use that as a clue, or kind of a key for figuring out what the soft tissue anatomy of these extinct animals was like back in the day. So that's what they're doing here. Super cool. Blood vessels, nerves and blood vessels. Nice. Cosmoceratops. I've worked on this specimen before at the Natural History Museum of Utah. This guy right here. And then this looks like Pachyrhinosaurus. Diabloceratops. I've worked on that specimen too. Uncle Don found that. Don DeBlue. That's his baby. And then Psittacosaurus. We were talking about our non-horned ceratopsians earlier, like Psittacosaurus. There you go, Murph. They looked at this critter too. So it's nice that they're not just looking at Triceratops. They're trying to get a sense for horned dinosaurs in general and what's going on with their noses, you know? Because maybe Triceratops is an outlier. Maybe it's the odd one out. It's nice to look across the entire group to get a general sense for what's going on in this clade, you know? Yeah. Let's do a quick search. MOR. Yeah. All right. MOR 591, Ionosaurus or Ankylosaurus. Okay. Is that really the only time that appears? Weird. Alright, maybe they didn't look at any of the specimens I helped dig up. That's... Oh well. Would have been a little too cool, maybe, to see some of my Triceratops specimens featured in here, but yeah. Anyway. And Care Dorian says, I might be a bit late, what was the use for Triceratops for the front horn? So, display is always kind of an easy answer for this. The interesting thing about Triceratops is the nasal horn changes a lot, not just as the animal is growing and developing over the course of its individual lifetime, but also through evolution, that nasal horn is changing a lot. When you've got a little baby Triceratops, we think that there's horn's just like a little button on the end, and then it fuses on as the animal grows and matures, to the point where it becomes a fused element of the skull, that nasal horn. But, we do have good evidence that over evolutionary time, so over maybe 1 million years or more, the nasal horn on Triceratops gets bigger and bigger and bigger as you go up in section. So over the course of maybe about 1 million years, maybe a little less, maybe a little more, as these animals are changing, evolving.
We have much to learn about the age of reptiles.
Vraylon, thank you for the follow. Welcome to Paleontologizing. Good to have you here. Thanks for clicking that follow button. The nasal horn seems to get larger over time. And we only really know this because we have so many specimens of Triceratops at this point. I think there were over 50 specimens that were looked at for this paper in particular. This is Fowler and Scanella 2014, I think. When you have enough specimens of a particular kind of dinosaur, and they're over a long period of time, if you're really careful about lining up exactly when in time they're from, then you can start to watch them evolve over time. This is the best case we have so far of this in dinosaurs, like watching a dinosaur lineage change over time. Watch these changes occur in the skull, most prominent of which is the nasal horn getting bigger and more prominent. Pretty cool stuff. So the idea that it changes, it gets bigger, maybe that has something to do with defense, but my default answer for this kind of thing...
A real dinosaur?
Venti Green Tea, thank you for the follow. Welcome to Paleontologizing. My default kind of answer for this, like, you know, what were the horns and frills used for? My default answer is display. because we've got so many different kinds of ceratopsid dinosaur, different morphologies of horns and frills over time, that if they were really used primarily for defense, then why are they changing so much, you know? You would think that there would be some kind of platonic ideal for the deadliest horn and frill arrangement, and that's not what we see. Instead, they almost change like fashion trends over millions of years. And like fashion, it's probably mostly for show. These are different kinds of horned dinosaurs here, by the way, different genera and species. But even in Triceratops, there seems to be like a fair amount of individual variation. And so part of having this elaborate headgear is probably individual recognition. You want to look different from your friends and neighbors so that other members of your herd can tell you apart, you know? And also, since these animals change so much through ontogeny, it's probably a signal that, like, hey, I'm this particular growth stage. If you're a member of the same growth stage and you eat the same things as me, let's come hang out. Let's form a herd. Maybe it has something to do like that. It's speculative, but, like, it makes sense given what we know so far about these animals. So, yeah. And Little Pig Pony says, do we think it's sexual dimorphism? No. It's a great question. But as yet, we've been pretty much entirely unable to tell the difference between male and female dinosaurs just based on their bones. It could be that, like modern crocs and birds, male and female skeletons just look pretty much identical, you know? So, yeah, it's not like they fall out into two discrete categories or anything if you look at all of them. It's much more like a spectrum, which just implies there's ontogenetic variation. So young and old individuals look very, very different. And then you also see variation over geological time. So again, you kind of see them evolving over maybe 1 million years in the Hell Creek Formation. But it's not like there's a binary where these ones look like males and these ones look like females. Nothing like that. Yeah. Maybe someday with enough of a sample size, maybe you could see two discrete categories emerging, but I have my doubts because it hasn't happened yet, and we've got probably a couple hundred different Triceratops specimens, maybe as many as 1,000 that have been dug up, and there's no clear distinction. Like, it's not like you've got two discrete categories or even two. We do not have a bimodal distribution. We'll put it that way. But yeah. And Wombat Hole says, how many millions of years did these animals show up in the fossil record? For Triceratops, it seems like it's about maybe 1 million years, or maybe less. We don't have firm dates for the bottom of the Hell Creek Formation. We know the top is almost exactly 66 million years ago. The very end of the Cretaceous. But the lowermost boundary of the Hell Creek is not well dated. And we might have Triceratops from earlier than the Hell Creek Formation in other parts of North America, but that's still kind of disputed. A good person to talk about this with would be Denver Fowler, and it would be cool to have a discussion about that sometime, but Denver's my old crew chief from when I worked in Montana. Yeah, so Triceratops is around for maybe 1 million years. I used to say 2 million years, but I think that time has kind of shrunk the more we learn. For ceratopsids in general, the big horned dinosaurs, they were around for not that long. It's like maybe 20 million years, something like that. So looking at our chronostratigraphic chart, we get our proper ceratopsids showing up. When is that? They're definitely around and widespread by the Campanian stage. So like 80 million years ago, they're already around. They probably go back earlier. So what would be some of the earliest ceratopsids? I think it would be like Diabloceratops, right? So Diabloceratops is one of the earliest of the true ceratopsids, I think. Yeah. Yeah. Diabloceratops eatoni was named by Don DeBlue and Jim Kirkland. Yeah. The Waweep Formation. Yeah, that sounds right. But yeah, Diabloceratops pretty basal. So it's an early diverging taxon. Ceratopsidae. What is our earliest ceratopsid? It might be Diabloceratops. Things like Zuniceratops are not really ceratopsids yet. Here we go. It is a ceratopsian, but not a ceratopsid. Yeah, so Ceratopsidae is there. I want to say Diabloceratops is the earliest one we've got so far. Which, yeah, that means that the ceratopsids, the big-horned dinosaurs, are only around, I guess, like in the upper part of the Upper Cretaceous period. So within, like, the last 20 million years of the age of dinosaurs, which is kind of nuts, given how common they are and how diverse they become. It's kind of wild, you know? They were latecomers. They kind of take over the world, at least the northern hemisphere, and they disappear when the asteroid hits. So, yeah. Anywho. And Kensei Zero says, so there's not even pelvic differences for egg-laying purposes? No, Kensei, we actually talked about this last week. No, it was on Saturday when we were talking about our dinosaur reproduction for Valentine's Day. Valendinos. One of my old roommates when I lived in Montana, Kevin Surya, he did a project about this where he was like, could we tell male or female dinosaurs apart by looking at the pelvic apertures? So he said, before we really look at fossils, let me look at living animals first. This is often what we do for when we're trying to figure out something that's unknown about dinosaur biology. We look at their living relatives. Crocs, who are kind of like cousins to the dinosaurs, and birds, who are literally living dinosaurs. They evolved from a dinosaur, so they are dinosaurs. He decided to look at birds. And so his project was looking at the pelvis, the hip bones of birds. I think it was, he looked at like geese and ducks and maybe chickens. And so he was trying to find if there were differences between male and female pelvis, hips. And the result was, no. There were not strong differences between male and female pelvic aperture size. In fact, the males had ever so slightly bigger pelvic apertures, but it probably wasn't statistically significant. So it's probably just like, with a larger sample size, that difference would probably wash out. So it's surprising that, like, you don't see sexual dimorphism in terms of pelvic aperture size. We don't see it in modern birds, so we wouldn't necessarily expect to see it in dinosaurs either. But that was surprising, you know? Yeah. That is surprising. I know, right? Kensei? Yeah. Yeah. I don't know if Kevin ever published on that. It was a null result, which I think is still really interesting, but it's the sort of thing that it's more difficult to get into a scientific journal. It's more difficult to get that kind of thing published if your end result is, yeah, we didn't really find anything, you know? I think it's important, but scientific journals might turn their nose up at it. So, yeah. And Kensei also wanted to know, what are the main differentiating factors between ceratopsids and ceratopsians? So Ceratopsia, the ceratopsians, that's the whole big group that also includes earlier guys that don't have horns or frills yet. Here we go. Oh, perfect. Thank you, Thomas Holtz, for this lovely image. Very good. So here's an evolutionary family tree of Marginocephalia. These are the dinosaurs that have kind of a shelf on the back of their head. This includes the Pachycephalosaurs. These guys are thought to be the closest relatives of the horned dinosaurs. So they also have like a shelf thing going on the back of their head. Anyway, so there's the Pachycephalosaurs up here. And then you get these ceratopsians. This includes early guys like Psittacosaurus. Here we go. Like this. This is a ceratopsian, a horned dinosaur, even if it doesn't really have horns. Got a parrot-like beak on that skull. Cool critters, Psittacosaurus. So they are ceratopsians, and then you get other later guys like Archaeoceratops and the Leptoceratopsids, and the Protoceratopsids like Protoceratops, and then you get more derived, I guess this is Ceratopsoidea, includes Zuniceratops, and then you get the later ceratopsids that are the full-blown horned dinosaurs. Even larger size, nasal horn, shearing dental battery. These are some of the features that mark ceratopsids as being their own family. So I love that Tom Holtz puts this text here in red to kind of tell you the synapomorphies of these groups, the different traits that define each of these groups. I say define, but that can change. If we find an earlier horned dinosaur with one of these things, then all of these things are subject to change, I guess. Yeah. And do kiwis show pelvic dimorphism? That's a good question, Claire. Kiwi do famously lay stupidly large eggs. It's a good question. I don't know. Yeah. And Red Cherry Pie says, why do you feel it's important to show a null result? Oh, great question. There's a number of reasons. I mean, for one, it's just useful information for something like this. To say, hey, we looked at all of these bird skeletons, and it turns out the males and females, their pelvic aperture is the same size. To be able to publish that and get it into the literature, I think is, for one thing, it can help save people that work in the future. If another student or another PhD researcher or whatever, if they have the same question and they find your paper in the literature, they can go, oh, somebody else already did this, and look at what they found. They can spend their time and research funds and effort on figuring something else out. They won't have to reinvent the wheel. But if you don't publish it, if a journal says, it's a null result, who cares? Other people might go and go down that same path and find the same result, and then how many different people have to keep finding null results, until it finally gets published? But also, it's a really interesting finding in and of itself. It has bearing on whether or not dinosaurs had osteological sexual dimorphism, if their male and female skeletons look different in any way. That's important information, you know? Even if you say, well, birds don't really seem to show this, that's still important, you know? That makes sense? Yeah. Anyhow. And Trick Track says, I assume that tetrapods started out using all 4 legs. Then these became bipedal and then back to 4 legs. Yeah, Trick Tracks, yeah. That's kind of the story of dinosaurs in general. So, yeah. Yeah, when land animals first, when land vertebrates first evolved, I should say. Critters like, Tiktaalik, when they first climbed up onto the muddy banks of rivers or lakes and started to pursue a life on land. I'm kind of oversimplifying here, but anyway, all vertebrate animals, all terrestrial vertebrates, tetrapods, amphibians, reptiles, mammals, they all evolved from a critter like this. So we call them tetrapods. It means 4-footed, because originally they walked on all 4s. So things like ichthyostega. When they first clamber up onto the land and start doing their thing, they gave rise to all the amphibians, all the reptiles, and all the mammals. They start off with 4 legs, which is why we call this whole group Tetrapoda. Find them on our tree of life here. But not all tetrapods have 4 legs. Not all tetrapods have any legs, you know? They start off that way, but there's lots of examples like, look at this Caecilian right here. This is a kind of amphibian, and they don't have any legs anymore. They've gotten rid of them. Birds only have 2 legs. They still have other limbs. They've got arms, wings. But yeah. Anyway, the first dinosaurs to evolve, things like Eoraptor, right here, and things like Panphagia. All of these guys walked on 2 legs originally. The very first dinosaurs, they all walked on 2 legs. And later on, different dinosaurs evolved other body plans. Again, the very first dinosaur walked on 2 legs, and all dinosaurs evolved from that. But some of them, they start to eat plants, their bodies get bigger as a result, and it just makes sense for them to start walking on all 4s. So you get the grand sauropods that follow that evolutionary path. You get the stegosaurs who do that too, and the iguanodontians, and the thyreophorans, things like Scelidosaurus, and later ankylosaurs. And the ceratopsians do that too. The first ceratopsians, again, were things kind of like, like Psittacosaurus, like we were talking about earlier. These guys probably walked around on 2 legs most of the time. But later on, as their descendants get bigger and heavier, they switch to quadrupedal locomotion. You end up with a big hulking 4-legged animal like Triceratops. So that's kind of the story of dinosaur evolution. They start off 2-legged, and then different groups that evolved from that initial ancestor independently evolved to be 4-legged, to be quadrupedal. This has happened how many times in ceratopsians? And at least once in thyreophorans. Probably several times within ornithopoda, but we'll just say 1. It happened in sauropods. So at least 4 times dinosaurs have evolved to walk on all 4s. If stegosaurs and ankylosaurs have... If they diverged super early on, before quadrupedality, then that would be at least 5 times the quadrupedalities evolved in dinosaurs. I think 5 is a good number. It's evolved at least 5 times, I'm going to say. It's probably a couple times with an ornithopoda. Yeah. Cool to think about, you know? Yeah. And Kensei says, but then some decided 4 legs good, 2 legs better. I don't think dinosaurs have ever... I think it's only ever been from 2 legs to 4 legs. I don't think any dinosaurs initially evolved quadrupedality from their bipedal ancestors and then switched back to bipedal locomotion. I can't think of any examples off the top of my head. Triceratops. I don't think so. Yeah. I think becoming a quadruped is kind of a one-way street for dinosaurs. I think it's permanent. I don't think anybody has ever gone from biped to quadruped and then back to biped. I can't think of any examples. Yeah. Murph says, did coelacanths have 6 movable limbs? Well, it depends. Are those second dorsal and anal fins, are those limbs or are they not? What is a limb? How do you define that, you know? We're talking about critters like coelacanths. With their... Well, maybe it's 7, because they've got the 2 pectoral fins, and then they have the paired second pectoral fins. So that's 4. And oh yeah, and then 5, 6. Okay, yeah. Is that 6 limbs? I guess it depends on whether or not you want to call them limbs, you know? And how cool, we're looking, this is the model from Animal Crossing, apparently. Nice. Yes! Pretty cool. That is a good model. Yeah, they did a great job with that. Anyhow. Yeah. Commander Caleb says it's kind of adjacent to your science, but anybody ever notice our science word for study of words and study of where words come from are homophonetic? You mean etymology? That's what you're talking about? Study of the origin of words and the way in which their meanings have changed throughout history?
Etymology.
Oh, I liked it better when it had a female pronunciation.
Etymology.
Etymology.
Yeah, I like this one better.
Etymology.
Oh, entomology, the study of insects, Commander Caleb? I don't know if they're probably different root words. Entomology is the study of insects.
Entomology.
Yeah, from the Greek entomon, meaning insect. So yeah. Those are what we would call, those wouldn't be homophones, they would be... What's the word for when two things just sound similar, but they're not exactly the same? Yeah. Anyway. Not similes, a simile is a, comparison of two concepts using like or as opposed to a metaphor where you don't use like or as, I think. Maybe a simile is a kind of metaphor, I'm not sure. But anyway, yeah. Would those be plesiophones? like plesiosaurus, the near lizard. Two things that sound similar. Homonym versus homophone versus homograph. A homophone is a word that has the same sound as another word but has a different meaning. They may or may not have the same spelling. So two, two, and two, there, and there, pray and pray. Homographs looks? What's a homograph? A word that has the same spelling as another word but a different sound and a different meaning. So lead and lead. Okay. Yeah. It reminds me of that joke on 30 Rock. I love this. And then they export it to Iran, so they have it in Persian. uh, 30 Rock was so good. Yeah. Anyway. How did we get here? You do, Lena, you will love 30 Rock. Holy cow, that I think will be your new favorite show. I know that's a big claim. Give it a try. Yeah. And you too, Rushwing, yeah. Yeah. 30 Rock is so good. It is. I've heard somebody say this before, and it always stuck with me. 30 Rock is like the closest thing that humanity will ever achieve to a live-action adaptation of The Simpsons. The way that the jokes just... they arrive thick and fast. Like, there's excellent satire. It's very rewatchable. There's a similarly zany kind of sense of humor, but it's also... it's not, like, dumb humor in the same way that, like, Family Guy or something like that is. There's a cleverness to it without being pretentious. Yeah, anyway. Good stuff. Does 30 Rock predict the future? Absolutely, XVR. In a lot of ways, yes. Yes. Was it written by Conan O'Brien? No, but Conan O'Brien definitely shows up on 30 Rock. Because I think Conan did he write for SNL at one point? Yeah. Astro Troy Gar. Thanks for the follow.
Help me.
Welcome to Paleontologizing. Is the Gar in your name a reference to the bony fish? To these guys? If so, very cool. Anyway, welcome. It's good to have you here. Yeah. let's get back to our paper. Oh, Astro Viking. Oh, gotcha. Astro Troy. Okay, cool. Welcome to Paleontologizing. Astro, good to have you. But yeah, cool stuff. Let's take a look at the conclusions of this paper, and we'll see if we have any questions about that to dive into. But I love this illustration. This is really good. And again, this is Triceratops prorsus. This is the one from the upper Hell Creek Formation. So this was the same species of Triceratops that was around when the asteroid hit. Triceratops prorsus with the big nasal horn from the upper Hell Creek. These should be flipped here. It would be more intuitive to have Triceratops horridus at the bottom and prorsus at the top. But prorsus has got the big, thick nasal horn. And, yeah. Anyhow, lovely illustration. That's so cool. I kind of want to print that. Have it on my wall. Logical perspective. I'm excited to read this, like, cover to cover. So conclusion, this study provides the first comprehensive reconstruction of nasal soft tissue structures, including the neurovascular system, nasal gland, nasolacrimal duct, and respiratory turbinate in ceratopsids, based on the EPB approach. The EPB, of course, is the extant phylogenetic bracket. I talk about this all the time. It's come up several times today in our stream. But if something is unknown about dinosaurs, a good way of organizing our thoughts and forming good hypotheses is to look at things that are known from maybe crocs and birds. Crocs who are like cousins to the dinosaurs, birds literally are dinosaurs. And these two groups bracket the dinosaurs. So this is the extant, meaning not extinct, alive today. Extant, phylogenetic, evolutionary family tree. Bracket, extant phylogenetic bracket, EPB. EPB approach. These dinosaurs are shown to have possessed a narial innervation pattern, so nerves in their nose, unique among reptiles, and inferred to have utilized an expanded nasal region, accommodating the respiratory turbinate for their cephalic thermoregulation. So, using a complex network of nasal turbinates to help regulate the internal temperature of their head. Pretty cool. Yeah. Neat stuff. I wonder if there's any other press about this yet, or if it's just on Paleontology News on Sci News here. Again, here is a link to that press release if you want to see it. Let's look it up on Google News and see if it's gotten any other attention. Here we go. Cool. It's nice to see this get some more attention. Excellent. Phys.org. Why Triceratops had such a big nose. The first comprehensive hypothesis on soft tissue in the dinosaur. Nice. If you spot a Triceratops in the wild, it may raise a question or two. First, aren't they extinct? I love that they put a joke into the press release here. And second, why does it have such an enormous head? Project Research Associate Seishiro Tada from the University of Tokyo Museum wondered about the latter while looking at a specimen, a fossilized one. I've been working on the evolution of reptile heads and noses since my master's degree, he said. Triceratops in particular had a very large and unusual nose. I couldn't figure out how the organs fit within it, even though I remember the basic patterns of reptiles. This made me interested in their nasal anatomy and its function and evolution. So some of the same quotes are in here from the other press release, but yeah, this press release has been written a little bit differently at phys.org. Dinosaurs exhibited a wide range of skull types, contributing to their visual diversity, which is part of their appeal. Horned dinosaurs, or ceratopsids, had some of the most elaborate skulls, with Triceratops being iconic and instantly recognizable. But due to its relative uniqueness, the internal anatomy of Triceratops skulls is also poorly understood. So Tada and his team set out to explore the internal soft tissues using the tools at their disposal. Employing X-ray-based CT data of a Triceratops, as well as knowledge of contemporary reptilian snout morphology, so looking at modern reptiles and how their snouts and noses work. We found some unique characteristics in the nose and provide the first comprehensive hypothesis on the soft tissue anatomy in horned dinosaurs, he said. Very cool. Neat stuff. Very, very cool. Again, I hope this gets further attention, because it is really interesting, and Triceratops is such an iconic dinosaur. It's been very, very popular for a long time. For good reason, I think. Now, going all the way back to Sinclair Dino Land. Where's our trike here? Ah. And thank you, Ridla26. I appreciate the ongoing support. Holy cow. 29 months is a long time. Thank you, Ridla, for keeping me here online and helping support science outreach here on Twitch. It means a lot to me. Thank you. Anyhow.
Of his neighborhood. Triceratops, sort of a 30-foot walking battering ram. That skull measures 7 feet. The ankylo.
Ever since its initial discovery and scientific publication, Triceratops has just fascinated people. And it is part of that, I don't know, like the big 5 or big 6, big 7 dinosaurs that if you were to go out and do a simple survey of people on the street, what's your favorite dinosaur? Triceratops is invariably in like the top 3 or 4. It's my mom's favorite dinosaur. I think it might be my dad's favorite dinosaur, too. And I'm not going to complain and say, oh, everybody loves Triceratops. Because it is one of the coolest dinosaurs, objectively, I think. There has been more work done on Triceratops, and we know more about it as an animal than almost any other dinosaur. Any other Mesozoic dinosaur, I should say. We have more specimens of Triceratops from different stratigraphic horizons than any other dinosaur on the planet. Bar none. Over the course of, like, there's no other dinosaur where we can actually say something meaningful about how they're evolving over time using a big sample size, using a lot of data. Triceratops is the only dinosaur we can do this for. It is also one of the largest of the ceratopsid dinosaurs. Triceratops got big. You know, it's not a small critter. It is one of the very largest of the horned dinosaurs. Arguably the largest, but... yeah. Just an extraordinary animal on so many different levels. It's also one of the very, very last of the non-bird dinosaurs. So, when that asteroid hit, Triceratops was one of the dinosaurs who was wiped out by that. It was here when the big one hit, along with T-Rex, along with Edmontosaurus and Ectens, along with Triceratops and Ankylosaurus, and probably Ankylosaurus, and probably Pachycephalosaurus too. Well, the jury's still kind of out on that. But yeah, Triceratops was one of the very last dinosaurs. So there's a lot going for it, you know? There's good reason for it being so popular, so beloved, being so fascinating to people. And Toilet Gator says that scene in Jurassic Park has to have helped the popularity. It certainly didn't hurt. Yeah. Yeah. A scene here with Sam Neill and Laura Dern. This is one of the things that some of the later Jurassic Park movies are kind of missing, and especially the Jurassic World movies. Just like a chance for a dinosaur to just be a dinosaur. And maybe be a little bit vulnerable. You know? Just being a living animal, like, it's important to have that. And what was it that Sam Neill's character says? Here we go. There's a lot I would change about this depiction nowadays. But, just that sense of wonder is beautiful. And I think it kind of captures one of the reasons why dinosaurs are so fascinating. You know? I love that. Yeah. Oh, Triceratops, pretty special critter. I'm not mad that they're so popular. I think there's a very good reason for that. Yeah. But yeah, there is a bunch of things that I would change about this. Yeah, the keratin on the horns. We do have some evidence that maybe much of the frill was covered by that same keratinous material that covered the horns. I've worked on some Triceratops specimens in the lab that have this weird kind of gunky stuff over the top that may have actually been remnants of the keratin. Covering much of the face. I really like that in the Saurian game, they take that idea and they run with it. So their Triceratops skull is kind of all covered by keratin like this, which I think it's pretty likely. I love how brightly colored this critter is too. This is another thing that I would change about the Jurassic Park depiction. And yeah, the hands are all wrong. So there we go. Like you see that here. It's got like elephant hands. That's incorrect. They were not like that. Looked a lot more like this. So Fujiwara had a really good paper about this back in 2009. Where's that figure? Come on, Google Images. That's ridiculous. Okay. Alright, I gotta find it in my my files real quick, because it's not showing up on Google. Give me a second. But they're... Ceratopsid dinosaur hands in general have a very distinct look to them. And we've known this for a couple decades now at this point. We're coming up on a couple decades, I guess. There we go. So, reevaluation of the manus structure. So, changing what we think about the hands in Triceratops. Based on a beautiful specimen that they have there in Japan. NSM, I think, is National Science Museum of Japan. This, I think, is one of the same specimens that they looked at in this new paper that we're talking about today. Yeah, there's the different finger bones. So by looking at how these are articulated and looking at the shape, they're able to arrange these in a lifelike position. And the end result is this right here. So it would have looked like this from underneath. And this also matches up with fossil footprints. So the hands should look like this. The last digit doesn't actually contact the ground most of the time, but the other 4 digits do. So that is what the hand should look like. This is what it looks like in the Saurian Triceratops here. Again, they did a phenomenal job with this. Just beautiful. That's what it should look like. So yeah. And it kind of makes sense. Like, it looks very different from the feet, because these guys haven't been quadrupedal for that long. They're still kind of getting used to the whole walking on all fours thing. They're pretty new to it. So it makes sense that their arms and their hands still look like arms and hands. Does that make sense? Yeah. Anyway, Toilet Gator says any mistakes can be covered up with the genetic engineering stuff. Yeah, I don't buy that. It's like... I kind of like trying to make excuses for mistakes. I find that so tedious. I don't know. Feels like such a, like... You know, making excuses. Feels like a very, like, fanboyish thing that, like... I'm just embarrassed to do that, you know? I don't know. My primary interest in these movies is as movies and as pieces of popular culture. Like, as a paleontologist, I'm really interested in how my science gets communicated to the public. Hopefully it's communicated well. Yeah. I don't know. Hope that makes sense. Anyway, somebody really wants some attention here. I think she wants to go on a little flight in the laundry basket. So we're going to go ahead and wrap up today's stream now. A little bit early. But I think we can go right into Rhacodactylus. So let's go do that, and let's commence our wrap-up procedure. All right, Mini Pie, hang on just a minute. Let's put a Deinonychus skull under our credits. There we go. Let's see if Reiko is on still. Yes, excellent. There we go. Beautiful. Everybody, thank you for tuning in today. Thank you to everybody showing up in our credits, from new followers and raiders. Help get those viewer numbers up. I really appreciate that. To the subscribers and the gifters and the cheerers, the people who make these streams possible through their financial contributions. I appreciate that more than you know. It's the reason I can do this full time. It's the reason I can make a living as a scientist. Not have to worry about grant funding and stuff like that. It's a dream come true, and I appreciate that tremendously. Likewise, thank you, as always, to our moderators. Those people who make these streams possible through their vigilance and community-mindedness. Thank you for keeping this a safe and welcoming place for all different kinds of people who want to show up and learn about the fossil record, learn about natural history, learn about dinosaurs. Appreciate that more than I can say. Thank you, mods, as always. We're going to go tune in to Rakadactylus, who is a fellow scientist here on Twitch. I think he's talking about aliens from the perspective of like a cognitive scientist, so